Okay, yeah, that looks better. A bit more radius, I think. Yeah, and now we can fiddle a little bit with this. Right on. Okay, and look at this. This is pretty neat. Actually, like now we can actually put the next picture goes here like that. And yeah, this one goes there. And we're gonna need a couple of more icons, maybe this guy. Okay, right on. Bam and bam. Yeah, that's pretty good. So yeah, as you can see, like we created this in nearly 10 minutes. And yeah, like now you have a pretty, it's not amazing, but it's a pretty good UI that you created. And it's all 3D from scratch. And yeah, like this is an actual UI that you can now go ahead, create a video out of it, and you can share this UI with your peers. So this UI is proven that it's readable because you actually tried it, and it's totally readable. You can just like press it with your hand in case you are using HoloLens 2 or something like that. It's a pretty decent UI that would have taken ages to actually do something like this in Illustrator, and then you go to Unity or somewhere to actually iterate in this kind of design. And here we iterated in nothing, in 10 minutes. So yeah, here's that. So that's why I think Maquette is a super powerful tool that you should include in your current design toolset. Woo, that was intense. All right, so I hope that you learned something today. If you're looking forward to learn more, you can always go to our YouTube page where you can find a lot of new tutorials. Also, if you have any feedback, we are always looking to improve. So just keep in touch with us. And yeah, that's all for today. So yeah, have a good one, guys.
Hi, my name is Jia Wang, senior software engineer working on Maquette. We have actually found Maquette super useful in its own creation process since the very early days. And today I'm going to show you some example of that and how you can take your creation from Maquette, export it into 3D model files, and take that into Unity to continue your development there. Hope you'll find it useful. Let's go. We have been using Maquette quite extensively in its own design and development process. Today, I'd like to show you some example of Maquette's own UI designed in Maquette. So this thing here shows you early versions of the recolor tool interface that we prototyped in Maquette. Essentially, this is the final version. And in comparison, you may notice that the visual fidelity of this is not really good. That's because we were doing this sketch really early on in the product's development process. I think when we were doing it, we only had the brush tool that you can draw stuff, and the ability to swim around, and the ability to grab objects. And we intentionally did this very early on because we wanted to make sure that we are creating a tool that is useful. And what better way could it be than to design further interfaces of the tool by itself? The other part of it is that by using it every day and living through the pain points of using the tool, we feel more clear of what features we should add to the tool. And that really turned out to be very efficient in our process. And here I took one version of this sketch into the thing, and the benefit of doing this in VR is really clear. With my left hand, I can reach out and grab this, and now I have the hand UI on my hand directly without writing any single line of code. All of this is sketched in Maquette. I can already feel how that holds on my hand, whether the UI is too much or too heavy. If a button on the back is easy to reach, size of the objects, whether that's viewable from a distance, um, and whether it should be bigger, smaller. All of these are very easy to adjust in VR, and pretty much as quickly as you can model it, you can try it. And compared to the traditional 2D workflow where you would typically work with designers and 3D artists to actually sketch this on the whiteboard, then in Illustrator or Photoshop, and then model it in Maya, and then you bring that into Unity, and finally when you deploy to the device and try it in VR, it could be days or even weeks after your initial idea. But Maquette essentially condensed that lengthy process into like 2 steps. You just sketch it and then you just try it right away. If you have a team of people you're working with, designers and developers, and you're trying to communicate your design or doing co-design with them, it's just as simple as putting the headset on the person and having them try it. And you can also make modification as you are gathering feedback really quickly. And there are a lot of examples of this in Maquette. Like I said earlier, pretty much everything you see here in the tool's own UI went through the design process inside of Maquette. And this one is the slideshow or the scenes menu where I'm using to give this presentation. And we went through a lot of different versions of this, and it looks a lot, but it's actually really quick to create them because you can basically group one version of it and clone it, and then you can break it apart and rearrange the interfaces based on your feeling of it or based on another person's feedback. And this again is an example of like using the tool itself, letting us know what we need to develop next. Like we need to have a good clone tool. We need to be able to group objects and break it apart. And all of that was actually derived from our own experience of using it. And this is a clipboard that you see under the clone tool that you can grab any object and you can place it, enter, and you can bring it out in another slide or a different project. This is also another pain point. While we're using the tool, we feel we should be able to transition content easily between projects and between slides. And we sketched out this interface very quickly in Maquette. It feels great. And we really like this idea of putting the 3D snippets on a shelf. And we use that idea and further develop that into different versions that can materialize in the asset menu. And this is actually pretty close to what we have. And this one is a context menu of the file browser. If you click the dot dot dot, we also, like many other interface, design this in Maquette. And the visual fidelity here is a lot better compared to the previous versions, and that's because this is more towards the later part of the development, where we had a text tool, we had ways to align objects better, and we have the gimbal to manipulate objects more precisely. Um, and again, using our own pain point to drive development and having that feedback into our further usage of the tool and make it better and better. And this one is a camera tool that was also designed in Maquette, which turned out into this real implementation. And this is one sketch of a version of the environment menu that we could have developed, but haven't got to it yet. Essentially, in Maquette, you not only can create static content, you can also use a space to sketch out how an interface would transition through different part of the interaction. And you could also use a slideshow as a way to create some kind of stop animation of how the interface would evolve based on user input. And right at this point, our team is actually working on a interactive UI library with buttons and sliders and checkboxes, all the common UI elements you would want in 3D. You can simply drag them out, and you can go to the play mode, and they are interactive. And our hope is that you can, even create interactive prototypes in Maquette, and that's really helpful too, in our opinion. And beyond UI design and iteration and design review, we also use Maquette for all kind of other things. We found Maquette interestingly useful in brainstorming and mind mapping in space. And this one is how we were using Maquette to prioritize our work, different features we could implement, and how they are falling under different groups, and what kind of prioritizations we could give them. We don't have to do this in VR, but we found it very fun to do it and very intuitive to discuss it in space. And this one is probably a better example of how that could be better in VR. This is our roadmap, essentially. This is the features we could develop and their dependencies. And each of this is little stage or the little figure is actually a teleportable area. You can point at it and click the button, and you will be teleported to be like this, and you will see the 3D concept in front of you. You can engage in a discussion with your designer or developer right away. And you can also have a high-level view of like, where is the product at and what other features we are going to work on next. If you are working the team, communicating your idea or plan, or giving demo to other interested party, this is really fun and effective too. You know, since you are designing and creating all immersive 3D concept and interfaces, doing this in VR has a lot of benefit to streamline that communication process as well. Even Maquette's own logo was designed and iterated in Maquette itself. And here I'd like to go through a very quick example of how we used Maquette to design and develop the start space or the home space. What I mean is, if you go to here, this is the final version of it. It is a headlocked curved UI in front of you that's presented to the first-time user, or if you choose to come back to it. It shows you a list of example projects that we have developed and other users have developed as examples to showcase what Maquette can be useful for, either art, design, whatever you want. And also present you a list of tutorial videos that show you the basic interfaces. And of course, we didn't come up with this UI just directly off the top of our head. We went through a lot of iterations, and we did that in Maquette, of course. So here I took some versions of that design into this slideshow to show you. You can pretty much teleport to the central spot, and then you can pretty much try to reach out and kind of get a feeling of how that interface feels in space, whether things should be a different color, or it should be arranged differently, or maybe things are too big to reach or too small, whether the text is readable from this distance, and or whether everything is filling in your field of view or not. So all of this you can do while you're creating it. It's really powerful. You don't have to wait of any development in Unity, or you can see it right away, and you can make adjustment on the go as well. So here I probably grabbed more than 10 examples of this different layout. In fact, in our own original home space design project, we had more than 50 of this, and they were really quick to create too. I think our designer originally had 20 of them, and then we did design review together, and as we were giving feedback, our designer was making changes by just cloning the slide and start moving stuff, and then you get more and more versions, and we finally feel that we should have something that's more or less fit in your field of view and should be easy to target, and we reached this version that is what you saw earlier in the final implementation. But what you see here in Maquette without the implementation is pretty close to what you see in the final version, and that's really the power of this. You can even reach out and grab this. This is actually a brush, a straight edge brush, and use it as a pointer to see if things are reachable from this distance and so on. So I have shown you a lot of examples of like how Maquette is useful in the UI design iteration. It is also very useful in the development process for me as a programmer to use this in Unity, because previously in the traditional desktop workflow, most of the time I get is a PowerPoint slide, which have a polished sketch of the 3D interface, but on a 2D surface. So I have to do a lot of guesswork to figure out how to implement that in Unity. But here, everything is in 3D already, even in VR already, that I can just select this whole thing and go to the select menu and use this export button. Let me give it a name. VRUI. And then I can choose to export it into FBX or GLTF format. And we have a Unity editor add-on that you can put into your project, and that would streamline the import process of these models, and you would get prefabs in your Unity project. I would demonstrate that in the next step. So yeah, let's jump onto the Unity editor to continue this. So you can go to our website to get the Unity editor add-on. Just go to maquette.ms, and on the top, Unity add-on, and scroll down a bit. There is a link which will download the Unity package file. And we also have instructions on the website of how to utilize this to import your model. Here I have a new Unity project that I already imported everything from that package. You can download from the website. And under My Documents, Maquette Exports, you can see your export files in different formats, FBX, GLB, or GLTF. And they can be imported into Unity just as simple as drag and drop. So here I can just take this one and put that in the models folder. And within a few seconds, the add-on would capture that and generate a prefab with all the correct materials and group hierarchy preserved under the prefab. So this is how you can also name these groups in Maquette, and all of that information is correctly exported and preserved. This is really helpful if you are going to use this as a reference in space. For example, when I was coding the home space in our project, having that reference in 3D was really helpful. I could implement a visualization of this UI in C#, and then that version of the layout can be matched to the reference to make sure it's correct.
All right. Thank you very much for tuning in today. Hope you have found something useful here. Please give Maquette a try and let us know what you think. Goodbye.
Hang on, Jia, you're muted.
Sorry. Thanks for watching the video, and we hope you found some information useful. And we'll go through some of the questions now. So I have seen a few questions asking about Quest support. Definitely, we have heard that feedback from our community. Getting on Quest is quite challenging, aside from supporting out of Steam on Oculus. We also need to solve the perf problem. And our team has been actively working on optimizing the performance of Maquette, and we made a lot of progress. But there still remains to be a lot of challenges on that. So we cannot give a definitive answer of the release about that as of right now. But recently we have released on Oculus Store, and you can use link cable to run Maquette on Quest, which is what I think what Ricardo recorded that video based on. And another question that was asked several times was about multiplayer in Maquette. And again, our team also feel like really excited and of that idea too. It does take a lot of effort to build. So we took a different approach to enable you to do design review with another peer that's on the desktop using mouse and keyboard. And we didn't show this in the video, but if you launch Maquette, the desktop window has UI for another person to navigate the same thing with WASD and on the keyboard and the mouse. And in VR, the person working in VR would see an avatar and will see a pointing ray that's indicating where the other reviewer is indicating in VR. So you can do some collaboration there. Meanwhile, we are constantly thinking about like how we can make this collaborative in VR. There was a question about future plan. So Ricardo gave you a glimpse of what we have been working on. UI, library, and interactivity is what we believe strongly that would take Maquette to the next level to allow you to create interactive prototypes. And we were also thinking about the meaning of that and how that can work in Unity when you can export those UI. So that's one part of it. And perf work was another one that we are trying to get it running at a consistently good frame rate. And we are constantly listening to your feedback on the Steam community and fixing bugs as well. Yep. And another one I read here is about Maquette created content, whether you can use that in places like CliffHouse or Allspace or VR Chat. So I showed in the video that you can export your content into a few different model formats, FBX, GLTF, GLB. So any software that or any framework that takes that as input could potentially leverage what you create in Maquette. And we have tried to do that into the CliffHouse and can confirm that works. So you can export Maquette saying into a GLTF or GLB file, and on our website on Microsoft MR, there is a toolchain that can kind of like process that file to make it CliffHouse environment compatible, and then you can get it there. And the thing is teleportable, and you can just use it as your background environment. Let me have a look. I think there are a few questions about specifically how quickly you can design at the level that was showing in the video, and certain tools, how that can be effectively used. I think Ricardo can answer those questions very well.
Sure. Hi, guys. Yeah. How many hours of practicing do I have, like in Maquette? Obviously, since I work in Maquette, I do have a lot of hours of practicing. But I have to say that we tried to make Maquette very simple and straightforward. So the main workflow, it's actually super simple. So most of the time you just like put things on the scene and adjust them, and adjust the size or snap it to another surface. So really, you just need to learn, let's say, like 5 main things to actually start using Maquette. We try to make it as simple as possible, so you don't have to be a professional, you don't have to be a designer, you don't have to be super talented since you have already a lot of assets that are built in the app.
So you just like put the stuff that it's already there and you just put it in your scene. You obviously need to practice a little bit, but it's not as hard as, I don't know, using Illustrator or Photoshop, where you actually need to learn a very big tool. Maquette is not really that big yet. And yeah, I would say that it's fairly simple. If you are creating a VR app or you're creating a UI, a 3D UI, now with this new functionality that we are working on, it will be even easier. But again, you don't have to be a professional and you don't have to actually be have to prototype a UI. You can prototype whatever that is, and but it has to be special. So if you are creating something in 3D that like it could be like a HoloLens app, a VR app, or a 3D environment, you don't have to spend a lot of hours to actually do it in Maquette. You can do it right away. And Maquette is free, guys, so just go and download it and try it. So yes, let me check if there is another one that I could answer. If it's Maquette just for prototyping, well, Maquette is right now just for prototyping. We've been discussing if we could evolve Maquette into something more serious, but so far it's just for prototyping. We've been working on a lot of different ideas, like this UI framework that we've been working on. We've been also working on allowing scripting, but all this stuff is still rough, so it's not obviously public yet. But yeah, we're working on different things. Yeah, I think that we are mostly done and we are running out of time. So yeah, thank you very much for listening to us. And I really hope that you can try Maquette. We are on Twitter and on YouTube and on Instagram, I think. So if you have any more questions or you need resources, you need help, or you find bugs, because there are still a few bugs, just let us know. We are always listening. We are eager for your feedback. And yeah, thank you very much for making Maquette happen.
You're muted, Nick.
Thank you. Thank you so much, Gia, and thank you so much, Ricardo. That was a fantastic presentation and excellent answers. Thank you, audience, for sticking around for that. So we're going to have a quick break here. This will be until around 10:30, where we will have Alex Turner back with us to speak about OpenXR. So feel free to grab a bio break, pour some coffee, make some tea, take a breath of what is hopefully fresh air outside, and be back here at 10:30 for some more excellent content. So stick around, and we'll see you in a bit. All right. Welcome back, everyone. We're going to get started on this next section. So up now we have OpenXR, cross-platform native mixed reality by our very own Alex Turner. So OpenXR is a topic that is very near and dear to my heart, and it has been ever since it launched last year. So I'm very excited to have Alex with us to talk about it, since he helped write our implementation of this. So without further ado, I'm going to launch into this video. And as before, we've got a Q&A box, one of these places. So prepare your questions for our expert, and he will get to them as soon as the video is over. So please enjoy.
Hello, my name is Alex Turner, Program Manager on the Mixed Reality team at Microsoft. Primarily, I work on APIs, making sure we have the right base level native APIs to power all of the mixed reality goodness on top. We started out with a native API set we introduced for HoloLens 2, and we brought that to Windows Mixed Reality on the desktop. But what I'm here to talk to you about today is the next generation of native APIs for mixed reality, the OpenXR API set. So the first question, what is OpenXR? So OpenXR is an open, royalty-free API standard. It's from Kronos, the folks who bring you OpenGL and Vulkan. And it gives you native access to all sorts of devices from all sorts of VR and AR platforms, devices that span the mixed reality spectrum. And this gives you one API you can use to target your native development, regardless of which platform you're ultimately going to deploy that app to. Now, when you're doing mixed reality development today, higher level apps in the stack generally handle this for you, right? If you're developing in Unity, you're developing Unreal, those engines will take care of figuring out, hey, on the back end, I'm talking to the Microsoft APIs or the Oculus APIs. But if you're the one writing that engine, that stuff becomes your job. And so what OpenXR gives you is a common API you can talk to handle all of the main guts of building an XR application, the core pose access, input, those building blocks you use to create an engine, but giving it to you in a common way that spans platforms. And OpenXR is the real deal, right? This isn't something, a side project a few of us got together to do. This is basically everyone in the industry getting together to realize that fragmentation will kill us, right? We have to expand the pie. We have to grow the industry. We can't just sit back and kind of fight over a tiny crumbs here and there to figure out, whose API is gonna win. That's not where winning is going to happen in this industry. It's going to happen from advancing the state of the art, pushing forward, and getting app developers to be successful on all of our platforms. Specifically, Microsoft believes that mixed reality has to be open in order to thrive, right? We've said this before. This is Alex Kipman talking about open stores, open browsers, and also open developer platforms. And specifically, Dom Box just recently announced that the time to embrace OpenXR is now. And given the momentum that you'll see today, you'll understand why. So in terms of key OpenXR milestones, right? Back in 2017, that's when the OpenXR working group was formed, right? Spec work started then, and Microsoft joined later in 2017. We worked together, and everybody brought their key insights, right? Microsoft and Oculus and Valve and Unity and Unreal. Everybody who was doing VR and AR today coming together to say, what key learning do we have from the APIs we've built that we can bring forward into this new API? And so by August 2018, we did that first demo at SIGGRAPH. We showed the promise of OpenXR with the same XE running on the Microsoft runtime and the Starbreeze runtime. And it's not the same way it is today with, let's say, something like OpenVR, where, yeah, you can write one app to one API, but you're still kind of going through a certain common layer, and that's bouncing down out to everybody's backing API, backing system underneath. This was the OpenXR loader directly pointing that at the Microsoft runtime and at the Starbreeze runtime, direct to the metal. By March 2019, we had the initial v0.9 draft of the API that we released at GDC. And we had Microsoft and Collabora both out there with runtimes that were able to run the same app code. And by July of that year, we got to the 1.0 release of the API that we released at SIGGRAPH. We were able to show across Microsoft and Vario that OpenXR was ready for engines to start building. And as of now, as of July, just a few weeks ago, we hit a key milestone where both Microsoft and Oculus have each of our conformant runtimes, 2 different conformant runtimes, not just available, but shipping to end users. And SteamVR is coming soon. And so this means that the time is now to start building your apps against OpenXR, your native engines against OpenXR, because customers are ready. So who's building their apps? Who's building their engines against OpenXR today? Well, a few weeks ago, we announced that Minecraft, which is revamping its render engine, they're rebuilding their game using this new Render Dragon engine they're creating. The VR support they're building into that engine, they're building with OpenXR. Today, when they want to target Windows mixed reality and they want to target Oculus, they're doing so with 2 different native backends. But now they're able to write one set of code, one OpenXR backend that serves all of those headsets. In terms of browsers, Chromium, powering Edge 79 and Chrome 79. There's the WebXR API to provide similar capabilities to web apps. Chromium's WebXR support for desktop VR, they're building that. They've built it in OpenXR, and that's been shipping since Edge and Chrome version 79. Firefox Reality on HoloLens 2, right? The way that you're going to access WebXR right now on HoloLens 2, Firefox Reality is also built on top of OpenXR, powering all of the demos you see here on HoloLens. Another great use of OpenXR, Nick, our host today, has built an easy-to-use C# code-first engine for targeting mixed reality, and he calls it StereoKit. And just with the code you see here on the left, you can produce this experience on the right, rendering a GLTF model and drawing it from whatever angle the user is moving around. And you can see all sorts of capabilities that are available in StereoKit. You have user input, you have common buttons and sliders, things that you can create, all done in this code-first way. And this is a great library that Nick has produced, but imagine if Nick had to target not just the Oculus API, but also the Windows Mixed Reality API. Then he wants to bring it to other headsets, other AR headsets. He would have to target their APIs. But because he's able to target OpenXR, he's able to really take his time and focus on features, focus on making the UI better, focus on adding more capabilities for using your hands for manipulation, all of that kind of stuff, because he doesn't have to implement everything 2, 3, 4, 5 times in the engine. And many more. Unreal Engine 4.25 now has preview support for using OpenXR as its XR backend. Babylon Native, you saw the Babylon.js logo before when we were talking about browsers, when we were talking about WebXR and Chrome and Edge. Well, if you want to take that same code-first JavaScript experience and you want to bring that to building mixed reality apps that run natively on a device, on something like a HoloLens, you can use Babylon Native. And their backend for Babylon Native is also being built in OpenXR. In addition, Blender 2.83, they now have VR preview for the objects and the scenes that you're building. And you can view things in VR on whatever VR headset you have using OpenXR. And importantly, if you do native engine development yourself, your engine can also use OpenXR based on all the stuff that you're going to see today. So how do you get started coding in OpenXR? So if you go online, you can find this image that Oliver and our team pulled together for learning the OpenXR API. And it's a great reference to have. And there's a version of this talk where maybe I would just kind of zoom around on here and have a bunch of slides that describe all these different parts of the API and what makes them tick. But I'd really rather show you this in code. And so let's jump into Visual Studio now. All right, so what I've got here is Basic XR app. If I go to basically our OpenXR homepage at Microsoft, I'll show you the link for this at the end of the talk. You can see here that we have some description of our OpenXR runtime. It shows kind of how to get started, the roadmap of what features we're releasing when, especially for HoloLens 2, where we have a set of extensions, and also how to get started. And if you follow the instructions in that Getting Started page, it shows a Basic XR app, a GitHub project that you can sync down, among other samples, and you can try out how to get started with building OpenXR. So that's the project that we've got here. And so the first thing you'll look at, if I look at the precompiled headers here, you can see among other things that are being included is OpenXR.h. So this is the core way you bring in the OpenXR header. And OpenXR, it basically is a loader. This is a header for a loader that goes and it finds the active OpenXR runtime that's active on the device. And so for a standalone device, like something like HoloLens 2, you're just going to have some kind of OpenXR runtime that comes with the system. So you're going to find the one runtime there. But on a device like a Windows PC, you may have a runtime that comes from Oculus, or you might have a runtime that comes from Microsoft. And so the loader enables one app to be shipped, which can then discover the current runtime. And that way your app doesn't have to be updated. If somebody else's runtime comes out, some new hardware comes out, you are able to support that headset automatically. All right, so now that we're including OpenXR.h, let's take a look at this application, right? It's a pretty simple application. It's more geared for readability, but you can see here in the main run method, we're gonna create an instance, set up actions in that instance. We're gonna initialize a system and then a session inside OpenXR. Then you see here, we're gonna jump right into our frame loop. In each frame, we're gonna go through, process events, poll for input actions, update our scene, and then go render the frame. So let's go dig in and figure out what each of these things do and how the OpenXR API operates across this map. So the first thing we're going to look at here is create instance. The first thing you want to get when you're talking to OpenXR is a handle to an XR instance. And as with many native APIs, when you have a resource that's being managed by the OpenXR runtime, you're going to keep hold of that and manage the lifetime, the life cycle of that yourself with a handle. All memory and all resources are managed by you as the app developer. So there's no things that are going to be created for you, on the heap. Then you're going to manage with reference counting. You manage the lifetime, the creation and destruction of these various OpenXR handles. And so right now here with instance, before we can get the instance, we're going to select first the extensions that we want to run with. And so if you're familiar with OpenGL, if you're familiar with Vulkan, this is where you have a core spec, but vendors like Microsoft, Oculus, Valve, and so on can come to that spec and introduce their own vendor extensions or collaborate across a set of vendors to introduce cross-vendor extensions. And this gives you that balance where the core of the spec is common, but it doesn't block innovation. Anybody who has a new capability that's an incremental addition over an OpenXR runtime, they can ship their runtime with that extra capability. And so if I dig in here to select extensions, this function, you'll see that we're calling XR enumerate instance extension properties. It's got the toCall idiom to get that list of available extensions. And then we have some code here that's just spelunking and making sure that the extensions we care about are available. And so the extension we require is the D3D11 extension. And you'll see here that the name starts with KHR. And so KHR just means that this is a Kronos extension. And Kronos extension is basically part of the core spec, but it's an optional part of the spec. And you see here, this is the extension that enables us to use D3D11. And so not every runtime is going to be running on an operating system that even necessarily has D3D11 support. And so it's not required that you support D3D11 when you build an OpenXR runtime, but because this app is built with D3D11 for its graphics, we're going to require that that extension is supported by the current runtime. If I then look down here, we're also adding in some optional extensions that we're just going to use if supported. And so, for example, if the runtime in question supports submitting depth, right, submitting your depth buffer to improve the stability of the scene for the user, we're going to submit our depth. But if the runtime somehow can't make use of that information, we'll just skip doing that. And you see here, there's some other extensions as well. This one's a KHR extension. But these other Microsoft extensions are available for unbounded reference space and spatial anchors. These are some concepts from HoloLens 2 that are also available on Windows Mixed Reality, but they might not be available on other headsets. And so we're going to use them if they're there, and we're going to skip them if they're not. So we'll go back now. And once we've got our list of extensions that we want to enable, we're going to set up this XR instance create info. And so a lot of the functions here will have this kind of info struct that you pass in, basically, to have this extensible way to send parameters in. And we'll send in kind of the API name, the app name that we have, and we'll call XR create instance. And you'll see what we're passing in here. We're going to get out that instance handle. And just a pattern that you'll see throughout this sample app. If I click here, go navigate into this put method. This is on a unique ext handle helper type that we've created inside this sample app. And the purpose here is just to help manage creation and destruction of these handles. You can see here for things like instance handle and session handle, we create a unique handle, and we mention both the handle type here as well as the destroy function, where when this unique pointer-like handle type goes out of scope, we're going to call that destroy function automatically, just to make sure that we're cleaned up. Okay, so we call create instance, we get back our handle, our XR instance handle. We're going to stash that away. And then we populate our dispatch table for the extensions. This is just a step you go through. I won't dig into the details here, but this is how you get access to all the function pointers for the extensions that you've pulled in. Okay, so now we've got our instance. And so now it's time to set up the actions that we're going to use for input and output. And these actions span across any sessions that you create, so you make them here up front. So if I dig into create actions, you can see here, we'll make sure we've got a valid handle. And then what we'll create is something called an action set. An action set is a group of actions that you can create, and then you can enable and disable them as a unit when you're syncing actions later, when you're getting per frame action updates for input. And we set up, for the left side and the right side, we can have these two sub-action paths. And then for things like here, placing a hologram, what you do is you create the logical semantic action before you decide what that binds to. So for example, we're creating here a Boolean action, and logically it represents placing a hologram, and we give it the name place hologram. And we say that it applies like left and right, so it has both of the sub-actions here. And then we call create action, and we create that action and store away the XR action handle for this place action that we've created. And we do so for all the rest of the actions, for pose action, vibrate action, and exit action. And so once we have all these actions, right, we've set up that we have these 4 different things going on in our app in terms of input and output, but we still haven't bound them to particular parts of a controller yet. And so what we say here then is for a given interaction profile, in this case, the kind of built-in KHR simple controller profile, we're going to decide if we see a controller that fits that profile, here are the bindings that we're going to suggest to the runtime as an application. And so for the place action, we're going to say that should be the right select and left select, kind of the main trigger or main button that you might have on a given controller. For updating the pose, for the pose itself, right? There's different parts of a controller you might want to track. So we're tracking what's called the grip pose, right? This represents the main body of the controller or the main pose of the hand if the system is using hand detection, hand tracking. For the vibrate action, we're using haptic output, and for the exit action, we'll use whatever menu button the controller has. And we've set up these bindings here, right? And this is a very simple app. You'll see what it does soon. It doesn't do very much, and so this is enough. But imagine here we were setting up a profile for, let's say, the Oculus Touch controller. And then something new, like, for example, the HP Reverb G2 comes out. And you haven't even updated your app. Maybe your app is still in some store, and it hasn't been updated yet to know about that controller. Well, as long as the runtime can say, hey, you've suggested bindings. You've set these bindings up and suggested them to the runtime for that particular controller. The runtime can then map that forward to whatever new kind of controller the user might be using. And this is the way we get not just back compat or cross compat across different vendors, but also forwards compat to new headsets and new controllers that might not have even existed when you shipped your app. Great. So now that we've suggested those bindings, we'll go back here. And we've got our instance, we've got our action to set up. Now it's time to go set up our session. And before we can set up a session, we've got to grab a system ID. We've got to know which headset it is that we're about to talk to. And so if I go into initialize system here, you can see we're making sure we've got a valid instance. And we then go into a loop where we call get system, right? Get system takes a form factor. In this case, the form factor we're going to pass in, it's set up in another variable, is going to be our head-mounted display form factor. And we're going to say, get me the system that represents this device, this PC in this case, this device's head-mounted display. And so if that succeeds, if we're successfully able to get a hold of that, if it's attached to the system right now, then we'll just kind of proceed on. If not, if we get the form factor unavailable error, that means that the user doesn't have a headset attached right now. They've set up a headset because we've got an OpenXR runtime here, but it's not attached. And so in this case, what this app chooses to do is wait 1 second and then go ahead and try going back through this loop to do it again. Depending on your app, you might choose different behavior here, right? If you have a VR-only app, you might go through this logic, or you might show an error message to the user that just says, hey, no headset is detected. Click OK when you've attached your headset. Or if you have an app that might do VR on the side, like a CAD application or a browser, in that case, you might just use this to know, hey, is there a headset available right now, even though you're not actually going to go trigger a new session. Just calling get system shouldn't be very expensive. It's something you can do very cheaply without triggering a lot of process creation on the system. It's something you can do just to ping and see whether a headset is available. And then when the user actually wants to use that headset, you'll later go and call create session. Great. So now, presuming we get through a success here, we've got ourselves a system ID. So what else do we need to do? Well, we now can take that system ID and we can enumerate environment blend modes. So what's an environment blend mode? Well, if we look at the enum here, environment blend modes represent the way that the system will take the pixels you produce as an app and then combine that with the rest of the world. So for example, on a VR display, the environment is not visible at all, right? So that has an opaque blend mode. You don't actually see anything going on behind the headset. On something like a HoloLens, you'd have an additive blend mode. You can create light, you can add light to the scene, to the world, right, with the waveguide display, but you can't subtract any light. You can only increase. If you want to make a shadow, for example, you have to create a glow, so you can put a shadow on the glow. Some headsets, though, will also support alpha blending. Right? There are VR headsets that have OpenXR runtimes like Barrio, where you can go and not just use the opaque mode, but you can also choose to switch to the alpha blend mode. And when you're in that mode, you can see what's going on behind the headset. And so by listing the available environment blend modes, as an app, you can choose, do you want opaque? Do you want alpha blend? Which actually matches the scenario that you're trying to do with your users. All right, so once we've enumerated environment blend modes, we'll pick the one that we're going to use later when we submit frames. In this case, this app can support all 3 of them. So we'll just take number 0. That's the preferred blend mode for this device based on the nature of the display. And now we're ready to go. So if we go back, now it's time to initialize our session. So we go in here, and setting up the session involves not just getting the XR side of things ready, but also binding what we're doing in XR, what we're doing with the swap chains that the runtime will manage with the graphics API that we're going to use. So this is where we start to do some things in OpenXR that are particular to D3D11. So you see here, there's XR graphics requirements D3D11 KHR. And this type ends in KHR because this is pulled in by that extension, that KHR extension that we declared earlier. So after we call this to get some of those key requirements, such as which adapter we're going to use, we do some more of our graphics initialization, and we get ready to pass in the system ID that we got before, but we also pass in this graphics binding struct through the next field here. And this is an important concept in OpenXR, so I'll dig into the struct. You can see the things you expect: system ID, create flag, stuff that makes sense when you're passing parameters to create session. But there's also this general pattern across all of these types where you'll have a type field and a next field. And what this allows you to do is take this base struct, but then chain other structs onto it. And so in this case, we chained on that graphics struct. But really anything can be chained. Any vendor can show up and have their own extensions that chain on to the structs that are passed into these various functions. And that's the reason they take these structs rather than just taking a flat parameter list. It makes it easier not just to expand the struct in future OpenXR releases, but for any vendor to show up and provide these next structs that you can attach to extend the functionality of the base API. All right, so now we've got our parameters ready for create session. We call create session, and we stash away the session handle that we've got. And so now we have our session ready. And this is the point at which the system is starting to get ready to go do the heavy lifting and really have an active XR session. So at this point, we've already made our actions before. And so we took the action sets that we care about for this particular session, and we're going to call attach session action sets. And this registers those action sets as being relevant to this particular session we're starting. And once we do that, we're now ready to set up some of these per session handles that we want. Remember, actions were per instance, but spaces and swap chains, which we're going to set up now, are per session handles. So if I dig into the create spaces function, you can see here we're going to start to create really the base reference space that we're going to use as a substrate for all the coordinate system reasoning that we're going to do throughout the app. And XR spaces, really, this is a place where as vendors, right, we all came together to bring our expertise to OpenXR when we were designing the API. Right, Valve had brought their input expertise, which led to a lot of that which you saw in actions. Oculus brought their compositor expertise about multiple compositor layers. And this is a place where, having built HoloLens, we realized there were ways we needed to extend kind of traditionally how VR APIs worked in terms of spatial reasoning to support not just reasoning around one room, but reasoning across an entire building, what we call world scale tracking. In the OpenXR API, it's called unbounded tracking. And so when you make an unbounded reference space, it has certain semantics that are optimized for being able to move around an entire building without having any lever arm effects from going too far. So if, when we were setting up our instance, we realized, hey, we actually have access to this unbounded reference space extension, then we'll go ahead and create a reference space of type unbounded MSFT. Otherwise, we're just going to go ahead and create a local reference space. And that works fine. It's just really geared for operation within 5-ish meters from where you start operating the app. Great. So now we have our reference space. We can call create reference space to go ahead and get that scene space handle we'll use as that substrate. We'll hold on to that for later. We're also going to get a space for that left and right pose action that we created before, right? Poses that you get for controllers, for input devices. Those are represented through the action system because that allows users to go into runtime UI, rebind that in case they want to change which controller is used for a given purpose in a given app, in a given game. But here, when we actually want to find it, we take the action, which we have here for finding that pose, and we create an action space. And we stash those spaces away to use later for posing the left and right cube that we're going to have in the app. All right. So after we've set up these spaces, it's now time to go and create the swap chains, create the buffers that we're going to use to render into that the system, the runtime, can manage to actually get this low latency rendering, this reprojected rendering out to the headset. So for create swap chains, inside this function, we go through, we can get system properties. This tells you, for that system ID, what are some of the key things the system cares about. And then specifically, we're going to go here to figure out the pixel formats that the device prefers. Different devices, different runtimes may have certain pixel formats that are more efficient, that get you closer to the metal. And so in here, we're able to enumerate those swap chain formats and figure out by taking the first supported format from that list that we know we can support, we're able to be as efficient as possible, both for color and for depth in our engine. Once we've got those formats figured out, we then go and enumerate view configuration views, right? And so the left and the right eye views for whatever view configuration we're selecting here. And if I go here to primary view config type and I dig in, you can see that the app, we've specified elsewhere, just like we specified head-mounted display, which we used before, we're also specifying the stereo view configuration type. And if I dig further into this enum, you can see some interesting stuff here, right? There's, the things you'd expect. There's mono and stereo built into the enum, but then there's some values here that have some pretty high numbers up here. And why are they such huge values? Well, if you look, these have per vendor suffixes. So this particular primary quad value, this is introduced by Vario, and the first person observer is introduced by Microsoft. And these are view configurations that are pulled in by extensions you might choose to enable that Vario and Microsoft have introduced. And so, for example, on HoloLens 2, if you want to use mixed reality capture and you want to do a render for that third render that you would need for the PV camera, for the mixed reality camera that sits just above where your eyes are in order to do a mixed reality capture video at high quality. Well, if your app wants to opt into that, it would then use this secondary view configuration. But we needed to extend the existing view configuration enum. And so a cool feature of how OpenXR works is when you introduce an extension, you get this range, you get a prefix here. You reserve an extension number, and that gives you a range in all the other like non-flag enums, which you can play around with to say, hey, not only do I need to introduce perhaps functions or structs as part of this extension, I also introduce these new values into existing enums. And so inside this range, we're able to get about 1,000 values here that we can play with. All right, so we've already chosen here, though, primary stereo. We're using one of the base view configuration types. And now we're ready to move on. So after having enumerated the views to get the left and the right views, we're getting some other key info about the recommended image rect width and height within that buffer. And now we go ahead and create our swap chains. And so if I go in here for creating the color swap chain, we set ourselves up with all the values that we care about, whether we're going to use texture arrays, whether we're going to use double wide, basically however we want to set up the swap chains for our application. And then we go ahead and create the swap chain. And after you've created the swap chain, the next thing you do is you prefetch the various swap chain images that are in that swap chain. And so generally you're going to have 3 images. Some runtimes may choose to use more for various reasons. In this case, we'll have 3. And you call XR enumerate swap chain images, again, that toCall idiom, and you get back out the list of images. And so in this case, we're going to have the 3 images that represent the 3 different buffers we're going to cycle through to do our rendering. All right. After we've got our color and depth swap chains, we're now ready to go. We've got swap chains figured out for our session. We've got spaces figured out for our session. And we're ready to enter our render loop. So now before we go into the frame loop, let's actually take a look at what this app does. So I'm just going to hit Control F5 here. And now I'll open up Mixed Reality Portal so you can see what I'm seeing here in the headset. And there's one main cube here. When I actually put the headset on, you can see that the app gets focused. It enters the focused state. And the app represents this by having the second cube move around the first one. And if I pick up a controller and bring it into view, you can see here, basically, I'm looking at my hand, in programmer art here, everything is represented as cubes. But as I turn my hand to face me and turn it away and rotate my hand left and right, you can see here the grip pose that I registered for before is updating and giving me live pose updates for the controller. And then if I actually pull the trigger on the controller, I'm able to place different cubes here in the environment, which I can then move around and look at in 3D. And also as I'm placing the cubes, I'll feel a little vibration that's created as I do so. So simple app, just designed here to show the same basic capabilities that you might have underlying any VR app, any AR app, but doing so in a cross-platform way with OpenXR. So let's take a look at how the frame loop works for this app. So now that we've created the session, we're ready to get going with our render loop, with our frame loop. But we haven't actually begun the session yet. We haven't told the system to do that transition, to show the system entering VR, and to actually start providing those frames and having reprojection happen. But we're ready to do so. We're ready to process the events that will get us into that loop. And so if I go in here, one of the key responsibilities, as with many APIs, is that you have to handle and drain events that come from the API. So each frame, we're going to go in here, we're going to call process events, and we're going to get events of various sorts. We can pull through this queue until we actually have all the events handled on our end. I'm not going to dig into every kind of event here, but the main kind of event that I really want to talk through is session state changed. This is the primary event that tells you when the core session state, the primary state machine for that session, is moving through the various states. And the first key state you're going to care about is ready. When the system reaches the ready state, it is time for you as an app to now begin the session, right? You get to this ready state, you make sure you're all set up with the primary view configuration that you chose, and you begin the session. And similarly, when for some reason the session is stopping, either due to you having requested that the session starts to exit, or the user exiting, the user actually going back to the home and you're being asked to clean up. Then in the stopping state, you would get ready and then call end session when you're ready to actually terminate the session and move on. And so, there's a lot of other stuff going on here, but those are the key ones. Make sure you wire up so you begin the session when you get ready, and make sure you wire up so you end the session when you get stopping. Okay, great. So we're processing the key events. We're going to have begun the session. And then at some point when we realize the session is running, when we get that event, when we actually get to the ready state and call begin, we're now going to start doing more inside our loop. We're going to start to poll for actions, and we're going to actually render the stuff based on the current state of our scene. So going into poll actions, you can see here we've got the active action sets. In this case, we only have one action set, the one that we created earlier. And we put that in the array, and we call sync actions. And sync actions is the key call that you do each frame to update all of the action states in OpenXR to represent the latest state for this frame, the latest state for all of that input data that you've bound your actions to. Once we've sunk actions, we can then go here, and then for kind of the left and the right side separately, we're going to process that hand, the left and the right hand. You saw me use the right hand before, and we have that cube that follows the hand as you move it around. So we'll skip this for a sec, and we'll go down here to place action. And this is the Boolean action that tells you if the user wants to place something at the moment, right? And to get the state of that each frame, we're going to call get action state Boolean. And we pass in the action handle, the place action that we created before, and the sub-action path, left or right hand, so we know which data we care about getting. And we're going to get that back out as place action value. And then we can now inspect place action value to see what's going on. So, if this action is actually active, if it's been bound to something, if it changed since the last sync, so we don't want to keep doing it if you've held it down. We only want to do it when you first press, right? So if the value of this bool changed, and if the current state is true, then we know that someone actually pressed this button, and we should take action to place an object. And so we're going to go through here and actually position our cube where that hand is in the world. But specifically, we don't just care where the hand is going to be. We want to care where the hand was at the exact moment the user pressed the button. Much of the stuff that goes on in OpenXR is often based on forward prediction, right? The way you do VR and AR rendering is you figure out where the head is going to be when the photons hit the user's eyeballs. Where is the head going to be pointed? That's the direction you want to render. And all the reprojection and things that happen are about fixing up the view so that it appears where that head is going to be. But for input, you care more about where stuff was, right? At the moment that the user pulled the trigger, if we know that the trigger was pulled, we're going to care about where the hand was back when the trigger actually got pulled. And so if I look here, I'm going to take this last change time. This is a value that comes along with Boolean actions to say, hey, when did it become true? When did it become false? And once I have that time, I'm now going to use that to figure out where should I make the cube? What was the historical pose of the hand at that moment when the press occurred? So now I go and I call locate space. And this is the key function you use in OpenXR to figure out where stuff is. You're always asking about where one space is relative to another space, another base space. And so in this case, the core space we care about for the various left and right cubes in the two hands, I'm going to care about for whatever side we're talking about, that particular XR space. And that's the space I want to find. And the base space I want to compare it to is that scene space, the underlying substrate space we're going to use for all the spatial reasoning inside our app. So I'm saying, where is the left hand? Where is the right hand relative to the origin of that base space? And I say not just the space that I want to find, but also the time. You're working in a cool API when you have both XR space and XR time as names in your API. And so we ask here for placement time, that last change time we got from the action. And at the result, we get the hand location. We get out the space location where that hand was. We test, we make sure that's valid. And if it is, we go ahead and call our own create hologram function to remember that pose and that time and use that to actually make an anchor out there in the world if we're on HoloLens, or just to pose this object if we're not. All right, and then one thing we skipped, we'll go back to now, is if we did actually make a hologram, we want to apply vibration. And so if I go back up to where we had set up the apply vibration code, this is the other side of handling input and output through the action system. This is output out to the controller to cause the controller to vibrate, right? And so you set up a haptic vibration with the amplitude, the duration and frequency you care about. In this case, we're using min haptic duration. This is something that helps you have compatibility across different runtimes, different controllers you might be using. This is a special value that means ensure the haptic pulse is short, but not too short, that it won't be felt with whatever motor is in use here. So we're going to use that min haptic duration, and we're going to apply haptic feedback to that controller. So whether it's the left or the right hand, that one's going to vibrate and tell users, yes, you actually placed this successfully. Great. So we've got this all placed. We tested input, we called apply output, and then we're going to do the same thing for exit and for some other actions going on here. And now we're done. We've processed the input for our application. So if I go back, now we've called poll actions here. We've set up our actions. Now it's time, we've done the update, it's time to do the render. So I'll dig into render frame. And this is another one of those places, right, where all of us, when we had our native APIs, like we kind of felt the elephant from different directions, and we ended up with somewhat similar patterns, right, for having the underlying native runtimes that we built manage the way that the frame loop is handled, the timing of how frames are presented and how the app is woken up to actually render into those frames. But there were subtle differences, right? We each learned as we went. We had different ideas. We tried stuff out. And so if you were somebody like Unity or Unreal and you wanted to target all of our different platforms, you ended up having to subtly deal with the slight differences in behavior with how frame timing, frame wake-ups, and such actually worked. And so one of the things we standardized that was pretty key for OpenXR pretty early on was that frame timing scheme. How we actually have all of us agree, even though we have some different ways and different IP across how our different runtimes actually operate behind the scenes, what is the core common API we can agree on for how you access that as an app, so you don't have to think about that. You can code once, and you get the benefit of everybody's best technology for how to keep that stable and comfortable. And so the methods here that you call is XR wait frame, XR begin frame, and XR end frame. So here you're going to see first XR wait frame. This is the key function you call to facilitate timing. This function will block until it is time to wake up for that next frame that it's your job to render as an app. And you're going to get back the frame state here, and this has some of the key data for that frame that you're rendering that you're going to need now that you've woken up. And we'll take a look at what's in there later. Once you're updated and you're ready to go and you actually want to begin doing your GPU work, you call XR begin frame. And XR begin frame here is really a timing point, right? This is a way that the runtime can know, hey, stuff that's happening before this point is maybe a bunch of preparation on the CPU. Stuff that's happening after this point, these are things that are going on the GPU. And this gives that feedback loop back to the runtime so it can make the right decisions. It can figure out, hey, for the next frame, given what I've observed of how long the app is taking, when am I going to wake the app up? How should I operate as a runtime to ensure the best experience for the user? So we call begin frame. And then we go through and we start setting up the layers. We prepare for the end frame, right? We actually have to go do the rendering at this point. And this is the composition layer system, right? You can have not just one main projection layer that you render out to. You can have multiple projection layers. You can have different quad layers. Maybe there's something that you're doing with the left hand, and your runtime supports stabilizing that independently from the rest of the scene because there's different motion. You can provide these different layers to the system, and then the late stage reprojection that the runtime does to update, even after your app is done with the frame, the runtime is going to take the latest best prediction for the head pose and reproject the pixels that you gave it. And it can do a better job if you give it different layers that it can then reproject separately to avoid artifacts. But in this case, we're going to keep it simple. We're just going to use one projection layer here. So we set up our projection layer, and we go through and we see, hey, is this a frame in which we should render? The system gives us a hint whether the user is able to see the pixels right now or whether there's some kind of other animation or something else that might be obscuring the pixels, obscuring the session at the moment. And so there's no point wasting time producing a frame that's not going to be seen. But in this case, we are in the visible state at this point once this is true, and we're going to go ahead and produce the frame. So the first thing we want to do is figure out where the left and the right eyes are. We set up this stereo view configuration, so we get ready to call locate views here. We say the view config we want to get the view data for. We choose the display time we want to locate for. In this case, this is one of those things on that frame state that we got from waitFrame. We choose that forward predicted display time. That's where we're going to care about the left and the right eye views for. And we ask for those views inside that scene space that we created. That's where we want to observe so we can create the view matrices in our engine. So we locate views, we get that data out. It has not just the data for locating the views, though, just like you get from locate space, it also has the projection, right? So you can create the right projection matrix there. You have the FOV data to construct that. Great. So I have that data, I move on, and now I go into render layer. It's time to render that projection layer for the left eye and for the right eye. If we've actually got a valid pose, we go through and we make sure, within the machinery of our engine here, we do some final updates to put the cube where it belongs, and we're now ready to go and actually render these cubes. So we pull out some of the handles that we created before, specifically the color swap chain and the depth swap chain that we had created back when we set up the session. And we decide for this frame what image rect we're going to render for. In this case, we're just going to render for the full size of the color swap chain. But we can shrink that down, right? If we decide to do adaptive rendering to make sure we're going to hit frame rate. And we could change frame by frame what portion of the full buffer that was allocated are we going to render into, and then we'll tell the runtime what part we did. But for the purpose of this sample, we'll just render the whole thing. And now that we know which part we're going to render into, we go and we actually get the swap chain image into which we're going to do the rendering. So here's a helper function we've written that goes through a similar cycle each frame to figure out a nested cycle what swap chain image we're actually going to go handle. So step one is to call XR acquire swap chain image, and the primary thing this gives you back is the index in that array. Remember, we got those swap chain images out before. This tells us which of those images that we giving back to us we're actually going to end up using for the current frame. Once we've got that handle, that image index, we're going to say wait swap chain image for that handle. And generally, you don't end up actually waiting here. This should just return instantly, but there's some different timing conditions in which this might block because that particular image still is required by the compositor. The compositor is still holding on to it so that it can maybe reproject it for another frame. So, we'll wait until this is available if we have to. And now we've actually got the swap chain image that we're going to render into. So we go back. We know which handle that is. And we get some key data structures set up here with all the just details about the color and depth rendering that we're planning to do. And once we're able to clear our frame, we go ahead and we do our normal rendering. I'm not going to dig into this, right? You can imagine if you've seen D3D11, what kind of code is going on there just to render some cubes. But once we're done, we've actually completed the rendering into that swap chain image that we were given by the runtime. We then are able to release it. So we go through and say, hey, release swap chain image. And this says we're done with this image. The compositor can now pick up this image and make use of it to get stuff ready for presenting out. And the reason that these images are actually handled by the runtime, some other APIs in the past, you would make these images yourself and just kind of submit them. This enables really efficient access on devices that need special buffers for scan out, and so you don't have to have a copy. For example, on HoloLens, you end up having special bits that you have to set on the buffer in order to make it acceptable for scan out. And you wouldn't know necessarily what bits to set because that might vary by runtime or by vendor. And so enabling the swap chain to be controlled by the runtime allows for that kind of per platform variation to be something that's handled for you. So that way you're actually able to span across. So that's it for rendering the layer. So now that we're done rendering and we've acquired, weighted, and released the swap chain image, it's time to tell the system, here are the pixels I produced, but also here's my metadata about them. Here's how you know how to reproject them to actually get the best quality result out to the end user wearing the headset. So finally, at the end here, we're going to be calling XR end frame, and we give it some of that data. We give it the layers so it knows which pixels we're intending to show. We give it that environment blend mode so it knows whether we want opaque, alpha blend, and so on. But importantly, we also give display time, right? We tell it, hey, for this frame, this is what establishes that triplet between wait frame, begin frame, and then end frame. For this particular predicted display time that we had waited on, we started our GPU work, and now we're submitting it. We tell it, here is the forward predicted display time when these pixels should appear. And so the system knows, hey, I've got, as a compositor, I've got these pixels, I've got other frames. It can choose the right frames to show, to reproject again if the app misses the next frame, and so on, to ensure that best experience. And so after the call to XR end frame, we're done. Where we go back out here, we get out all the way out back to our frame loop, and then we loop around, right? And in a case where the session wasn't running, we would have to throttle in order to kind of go back again. Maybe we just wait a quarter second. But in the steady state for our frame loop, this is all we have to do. We don't need any extra waits because the XR wait frame that's going on inside here, inside this helper function, that call to wait frame is what keeps us on the clock. It's what keeps us on the right frame cadence that's going to ensure that best experience for our users. And that's it. You've just got a whirlwind tour of the whole OpenXR API, all the different bits and bobs you saw moving around in that diagram. And you got to see input, you got to see how we set up sessions, you got to see swap chains and spaces, and really all the core concepts, the basic building blocks of building an XR engine, including how you do that on top of any runtime, not just Microsoft's runtime. Obviously, we would love if you use our runtime, but when you build your engine this way, all of your users, regardless whether it's a past, present, or future OpenXR runtime, they'll be able to use your VR app. So let's go back to the presentation. You saw the core OpenXR API and really a lot of the basic concepts, but you also saw us start to use some of the extensions, right? Some of the key core, KHR extensions that are really part of the core standard, but also seeing some MSFT extensions that we were referring to. And really this extension model is what gives OpenXR its power, what lets you get the best of both worlds. You have all the capabilities that are in the core spec, but then if you're a vendor like Microsoft or Oculus or Valve, you can add your own hardware and software innovation as needed. You're not waiting for there to be ratification. You can produce that and ship that right away and get stuff out to your users. There's no delay. You're not forced to wait for something, if you're using OpenXR. But obviously, that's not the right state of affairs to stay in, right? If everybody only ships vendor extensions and all the features really started to gather up there, you'd be back where you started. You'd have all different ways to do everything rather than having common extensions for common features. So from there, you can graduate to be an EXT extension. These are cross-vendor extensions that a set of companies got together to implement things like hand tracking and eye tracking. You come together to agree, hey, here's actually common structures, common formats, common joint sets, things like that. And if we can agree on this, we can produce one pattern that you address, and you're able to target everyone's platform. And obviously, if there's 2 or 3 of us coming up with an EXT extension, it doesn't stop 2 or 3 other companies from having a competing extension. But so far, we've actually been pretty good about aligning across all the vendors to produce these extensions so far. And KHR, right? Like if something we officially as an industry really agree, this is totally the canonical way to get this particular thing done, it can then promote into the core spec as a real KHR extension. It's still optional because you might have some hardware that doesn't even have that capability or some runtimes that can't talk to that graphics API, things like that. But at that point, you can promote it in, you can get into the spec as this optional KHR extension, and it'll have all the same IP stuff going on as you have with all the core spec text and the main text of the main spec. So in terms of Microsoft features, how do we get features on HoloLens and Windows Mixed Reality into OpenXR? Well, we start from this initial state where we have app libraries. So things like QR code detection, scene understanding for finding planes and meshes, things like that today, even with our current native API, they ship out of band. That's kind of the initial way that you can ship features. And there's little ways you stitch that together through interop to figure out, hey, where is this thing in the world? How do I take this GUID and use it to get a space to figure out where something, some plane is placed, some QR code is detected. And so from there, like just interoping through that app library, it works at first, but you really want to get it to a real OpenXR extension. And so the next step is for us to define and declare that kind of MSFT feature extension. we've done that for some set of features, which you'll see on the next slide. But then after that, you really want to promote into EXT, promote into KHR, as we just talked about. So this is the way that we've been pulling features together, mostly for HoloLens. The industry has actually agreed for the most part on stuff in VR. So if we look at that set, right, the things on the left, this is most of what you saw today. Systems and sessions, reference spaces, stereo view configs, swap chains, the functions that control frame timing, composition layers, input and output for haptics, and how you actually integrate with graphics API in the core platform. But we actually have a bunch of extensions already for this stuff in the right column, right? And a lot of these are for HoloLens too, but some of them, like spatial anchors, can be used in VR, right? If you want to take the inside-out tracking tech that Microsoft has and use it in like a giant warehouse, right? And place anchors and load those anchors back up later. You can use that kind of stuff in Microsoft's runtime in VR. So we have unbounded reference space and spatial anchors. Those are the two extensions we kind of hinted at that you saw in the code today. Those are MSFT extensions right now. But for hand joints and for eye gaze, hand tracking and eye tracking, we now actually have agreement across Microsoft and Oculus, Ultra Leap, Magic Leap, Tobii. All these companies have come together to agree for these critical inputs. How do we actually represent this? How do we come up with common formats, agreed joint sets, all that across the industry? And we have EXT extensions for both of those. And you can see here how Microsoft can then build further, right? We have an EXT extension for hand joints, but Microsoft has some unique features around hand meshes that aren't quite standard yet. And so we're able to tack onto that our Microsoft extension without making divergence for the core hand joint stuff, whereas in industry, we actually are ready to agree. Secondary view configs doing mixed reality capture render from kind of that secondary first-person observer config that you saw in the enum before. That's something that's a Microsoft extension right now. And then scene understanding, those planes and meshes. That's that thing that comes in through that interop library, right? You use the scene understanding SDK that you can download today. And you can use it with our native APIs that are outside of OpenXR. You can also use it with OpenXR in the same way. And you use it through that next row, those interop bridge API, something called the spatial graph bridge. That's the way that you use that sideband SDK. And then when it tells you, hey, here's the GUID that says where this thing is, you use the interop API, hydrate yourself up in XR space, and now you can find where that thing is in the world. So how do you get started with OpenXR? Well, here's the key URL, aka.ms/OpenXR. This is Microsoft's documentation around OpenXR and how to get started. You saw me go to that page before. The instructions are here around, adding OpenXR to your native app project, and really pulling in that header, pulling in that loader. There's different ways you can integrate it that are discussed there. Specifically, if you're interested not just in VR, which today is about, but you're also interested in HoloLens 2, you can install the HoloLens 2 emulator, or if you're lucky enough to have access to a HoloLens 2 device right now, you can deploy your apps directly to the device. And also on that page, we scrolled past it pretty quick, but you can see the latest version of the OpenXR extension roadmap. All the stuff I showed you in that slide, but showing out into the future, what kind of other extensions are going to be coming over time. And you can go to aka.ms/OpenXR-spec if you want a shortcut to the latest 1.0 spec that Kronos hosts, representing all the extensions, not just the ones Microsoft makes, but everybody's extensions, so you can party in VR and AR and actually get access to that full set of capabilities while only writing the common stuff once. Thank you.
All right, hello. Yeah, so I hope you enjoyed the talk. It's a bit of a deep kind of geeky talk, but it really hopefully gives you a peek under the covers of what's going on underneath engines like Unreal, Unity, those kind of engines as they start to get forward and build OpenXR support. This is what's going on there. And for those of you who actually are doing native engine development yourself, hopefully this was a great tour that can get you started poking around to build OpenXR support into your engines. So let me take a look here through the comments. We've been publishing some of these comments here. So let me just burn through. Please do continue to post comments and like the comments that you want to see us talk about first. So number one comment, to be expected, what about Unity? Unreal happens to have published some of these previews already, but we expect, especially on HoloLens 2, as we start to introduce features that are only available through OpenXR, we expect to get to the point where Unity is also going to be using OpenXR. it's likely a matter of time at that point. But yeah, nothing in particular to announce today. So any insight of OpenXR getting similar app types as OpenVR has, overlay, background, and extensions or similar? And so a scenario like this today, building proprietary engine, targeting desktops, would you go with OpenXR or with multi-API? So I'll take the second question first. Definitely if you're building your own native engine on desktop or on mobile hardware, I would say at this point definitely OpenXR is the way to go. The really Oculus and Windows mixed reality, you're in business right now, your users are already there, they already have an OpenXR runtime ready to go. And Steam VR is coming pretty soon. So given that, your investment would be a lot more leveraged if you just kind of focus on building it once and optimizing for that. What we found is when folks end up building the multi-API approach, you can get sort of going pretty quickly in each API, but then there's always this long tail of chasing down frame timing and how do you tune this to make sure you're getting exactly the perf you want. And you do a bunch of that work, and then you kind of have to repeat most of it for each one of those API backends that you're using. So that work still exists if you're targeting OpenXR, but it's something you get to do once. The other part of that question was about overlays. And there actually are, if you take a look in the OpenXR spec, there is the ext_overlay extension. And there's a set of folks who are working there, and they're actually able to implement a good prototype of how overlays are looking to work in OpenXR, even without being part of a given runtime. They've done it using another feature I didn't touch on today called API layers. If you think back to kind of like D3D and some other places, people would hook an OpenGL, people would hook the API to say, oh, I want to add this capability to all OpenGL apps or do overlay type things before that was a capability in 2D in the platform. And they would hook the API calls, and it could cause problems if you had two things trying to hook the calls. They wouldn't always interface well. There's an explicit way that's done in Vulkan that's carried over to OpenXR, where you can register at a system-wide layer or as an app, an API layer. And that can basically intercept calls, introduce new calls, and basically create a new API on top of an existing runtime. And so there's a set of folks who are working on an overlay extension and prototyping that out based on that API layer system. So if you search for ext_overlay, you can find that text in the spec, and you can, where people are experimenting. There's a EXTX prefix, which kind of means things are experimental, and then you can download that API layer for that. Okay. And let me take a look at the further questions here. So yeah, is Microsoft Edge going to implement the Microsoft OpenXR extensions? So Edge is currently along with Chrome as part of Chromium. Google and Microsoft are working together to continue to build and maintain that OpenXR backend for WebXR in the browser. For OpenXR extensions, like in terms of Edge actually on the device, on HoloLens 2, on mobile devices, we are in the process of getting that going for kind of the new Chromium-based Edge, and that's what would bring WebXR support to Edge there. So we don't have anything to announce about when that would actually complete. For now, Firefox Reality is the best way to go do that. But yeah, at that point, Edge would be supported there, and WebXR has its own system for optional components, right? There's WebXR modules. So if you search for WebXR hand input, there's a hand input module that's being prototyped and designed right now. And so, OpenXR browser implementations like Chromium and like Servo behind Firefox Reality, those are using OpenXR or will use OpenXR to talk to the underlying hand extensions in OpenXR to implement the hand module in WebXR. And so another question, what is the difference between OpenXR and WebXR? And so, there are two APIs that are solving a similar kind of problem domain, right? Like, you're trying to solve getting access to core poses, getting access to spaces, setting up the session and, taking, primary display inside the headset, things like that. So, WebXR and OpenXR are really tackling a very similar problem space, but just for two different kinds of apps. OpenXR is for building native apps, and WebXR is for building apps inside of a browser. And so, there's a lot of learning actually, and I end up myself participate in both. So I have my OpenXR T-shirt, but I also participate in the WebXR design for Microsoft as well for helping make sure that it's going to work great both for VR and also for HoloLens. And so, as part of that, there's a lot of cross-pollination of ideas to make sure that the best ideas from OpenXR, make it into WebXR and vice versa. At least, definitely so far, they've really improved one another because we were able to design those together. But just unlike WebGL, WebXR is not like a direct projection of OpenXR. They're just independent APIs for those two different basically places you can run your apps. Another question, how about Leap Motion? So Leap Motion, now like the Ultraleap is basically the company that does that now. They were a key part of designing the hand extension, the EXT extension that we have now in OpenXR. And not just that, they've actually shipped an API layer. They've again used that API layer system to be able to overlay Leap Motion support on top of existing OpenXR runtimes on desktop. So definitely, if you're someone trying out OpenXR for desktop VR, definitely go search for Leap Motion OpenXR and check that out. Let me take a look here. Just let me take a look at the new questions, for example, for a second before I go back to the published ones. Let me actually just go through here. I'll just publish a few more of these, and I'll go back to the published list. Okay. Yeah, so let's keep going here. Is OpenXR only for determining which device type is connecting to the app? Will OpenXR replace or supplement MRTK for HoloLens development? Will the first generation of HoloLens device be supported by OpenXR as well as the second? So I'll go through those questions in order. OpenXR is, just think of it as like a different layer of the stack from something like MRTK. And so if you think of somebody, if you're in Unity, you're using MRTK, and let's say this happens to be some future version of Unity that is based on OpenXR, then the stack would be kind of at the bottom layer, you have the hardware, and OpenXR is that kind of direct API that gets you access to that hardware. And it gets you the low-level access to poses and input and so on. Unity is then built on top of that. Unity has an XR SDK plugin system. That's how you get XR functionality into Unity. And so the plugin, if it was OpenXR based, would be built on top of all the APIs that we looked at today. And then once you have Unity exposing the base concept into Unity's scene graph using Unity coordinates and access to all the the Unity hierarchy and everything else, and they're inside the engine, MRTK is then that other layer on top of Unity. And so it's not that OpenXR replaces MRTK, it's just a different layer of the stack. And as we start to move to OpenXR-based features on HoloLens 2, MRTK, will be able to kind of target that through Unity, and we should be better together. The next part of that question was, will the first generation of HoloLens device be supported by OpenXR? So the first generation of HoloLens device is no longer receiving OS feature updates. And so, unfortunately, we're not able to add OpenXR to HoloLens 1 because that would be kind of the feature work that we'd be doing there. But yeah, it is on HoloLens 2, and it would be on any future devices. Support for 3D stereo and third-party tracking systems common to caves and other projection systems. Yeah, so caves and kind of 3D monitors like Z-Space style monitors that are head tracked. Those were both scenarios that we did consider while we were kind of fleshing out OpenXR originally, while we were thinking through the space system and other things there. We decided not to put those entries into that form factor enum that you saw, just because we don't have anybody who is trying them out today, and we were less confident that we would exactly get that right. And certainly, like, you would need to have a runtime, like whoever ships that monitor or whoever ships that cave system would need to build the runtime that enables access to that hardware. But when they do so, they would be able to very naturally extend that form factor enum to represent the form factor that they're targeting. So hopefully, if there's interest from those vendors to participate, right? I mean, like you saw ZSpace in the kind of OpenXR list, right? If they decide to publish that runtime, that would be like how I would expect that to work. They would extend that form factor enum, and then their runtime would allow access to that headset. Okay, here, let me just scroll again, make sure I'm getting all the questions here. Oh, and Nick, by the way, if you look at the Leap Motion question, Nick linked to the Ultra Leap OpenXR hand tracking repo on GitHub. So you can go find that. Okay, so I think that's all the questions that are currently published. I'll take another pass through the unpublished questions so I can push them out. Okay, so let's see here. Yeah, so one question, are there any plans for OpenXR IK, or at least some form of standardized logic to allow developers to target full body trackers or devices with extra trackers while still having code work with devices that only have the standard 2 controllers headset or devices being tracked? It's a great question. It kind of leads into a bigger question around input plugins, right? How do you actually get other input devices into an OpenXR runtime that exists? If you had looked at OpenXR before, kind of in the past, there was a diagram kind of had an interface on 2 ends, right? There was the application-facing interface for, which is what we talked about today, that helps you build an app that can then be kind of cross-compatible across different runtimes, but also forward-compatible to future runtimes. And also, though, there was a device plugin interface, and the idea was maybe you'd have one common OpenXR runtime, and then different headset device plugins would plug into it. Kind of since then, we've evolved our thinking in the working group. We started to look into in great depth, like what would it look like to produce this device plugin interface, and at some point to actually have the full power, like if you want to enable hardware composition and other things, you end up exposing another API that almost looks exactly like the OpenXR API itself, right? And the contract to implement that device plugin as a headset vendor looks very much like the contract to just implement an OpenXR runtime. There's not actually very much you get from the parent runtime if everything can be delegated down. And so we've kind of moved away from the notion that a headset vendor would produce a plugin that comes in. But a key place we do think that there would be high value in having these kind of plugins would be for input, because a lot of input devices are incremental to an already existing XR system. And so as a great example, like that Ultra Leap hand tracking API layer, right? It's implemented as an API layer for now, and it's actually impressive how far they can get just using the API layer system the way that it is. But what we want to get to, hopefully at some point, and this is future work for the spec, would be to have a legit device plugin interface so that folks who want to come with their own correlated tracking system, or folks who want to inject that IK can do so in a way that is a little bit more integrated with whatever runtime is being used. But at least for now, you can actually get pretty far with API layers. And so I would actually say, give it a shot, like whatever kind of stuff you would want to build in that way, try it out with API layers and let us know where that falls short, and that'll help us prioritize what kind of input device plugin features are most necessary. Okay, see, scrolling through here. Yeah, link to the reference card. Let me just double check the link that that Nick posted here. I was hoping somebody would jump in and post that, which is awesome. Yep, that's it. So yeah, so that PDF is great. The one that's linked there. It beyond having that reference image, it also just has a whole kind of index that lists out all the various APIs that are part of OpenXR. So if you just kind of print that reference card out and keep it handy, even sometimes I just search the PDF. It's sometimes easier if you just want to remember what something is called to look through there rather than look through the full spec. So that's a great thing to have. Let's see here. Raver's question, we talked about OpenXR having overlay apps. And the question was, can they run at the same time as the scene app so runtime becomes like a big multitasking operating system? If yes, will all big VR runtimes such as Oculus, WinMR, and SteamVR support them? So, I mean, that EXT overlay, the EXTX overlay extension that's out there, that's the key candidate right now for how we would do those kind of overlay apps inside OpenXR so that they could be supported by different runtimes. Right now, there's no OpenXR runtimes that natively support that. And part of it is that when you get into that layer of the stack and you're dealing with focus and, hey, when is the overlay app able to receive input, and when does one app receive input versus another app, and how does that relate to the system UI? It gets a little bit closer to stuff that is more divergent across, how Oculus works, how SteamVR works, how mixed reality works. And so there's just more to work out there. The API layer that implements EXTX overlay for now can get pretty far. I would say it gets 70 or 80% of the way towards the experience that they would want to expose. But there are some of those gaps. And actually the process of doing the API layer first has helped us figure out a bit where some of those gaps exist between different runtimes. So there's definitely interest in going in that direction. I think we're just having to figure out how we can reconcile the way those different things work. As you mentioned, it would enable the runtime to sort of be its own like multitasking operating system. And that's not a simple thing to create, especially in a way that is exactly compatible across multiple vendors. So we'd want to get that right. Let's see, do you see WebAssembly affecting OpenXR positively in the future? Does it currently? Apologies if off base. No worries, it's actually not off base. WebAssembly is a great tech that combined with other things like WebAssembly, WebGPU, or even just WebGL, web workers. A lot of these things you can start to get threading and direct GPU access and native code performance. WebAssembly gets you basically almost to native performance. The percent loss is not nearly what matches kind of maybe sometimes the FUD we have in our head around how JavaScript works. And so WebAssembly is key to getting at least cross compilation from maybe desktop engines in there, and to bring libraries over. What's interesting, though, is that you have some engines like BabylonJS and Babylon Native where you can kind of span across with the same code from the JavaScript realm into building a native app, or also building in the web. And they get very good performance even without necessarily leaning on WebAssembly. But for folks especially who have native code that you want to pull in, let's say if you want to do CV against images that are being captured by like an AR phone or something like that, definitely WebAssembly is critical if you want to pull that logic in without kind of rewriting it, and if you want to maintain that perf. Will the code I showed be available? Will this be the same OpenXR API Qualcomm is baking into the new VR chips? So the code is available if you go to that aka.ms/OpenXR URL. If you go through that getting started page, there, it'll take you to that next getting started page. And if you just search for basic XR app in there, there's lots of getting started stuff there, but one is like, hey, how do I get started actually writing an app? And that's kind of the sample app. In lieu of having like a VS project template, that's like the sample app that we send folks to. And then, you asked, is this the same OpenXR API that Qualcomm is baking into the new VR chips? Yeah, Qualcomm is key participant in the OpenXR standard. And so they are, maybe not precisely baked into the chips, but they have, VR capabilities, just like, Oculus Quest and Windows Mixed Reality and all of these VR capabilities. People, would previously create proprietary APIs for exposing those, lowest level hardware capabilities. How do the capabilities escape the OS to get to an app developer? And then you might have stuff like OpenVR that kind of wraps that. And so the idea with OpenXR is it just is the base level API for how you get to those capabilities. Just like on that Qualcomm chip, if you're targeting graphics, you might just use OpenGL directly, and that is the way that you would talk to the graphics library there if you're not using like Vulkan. So that's the idea that Qualcomm is on board with OpenXR, and they also want that commonality. So somebody who's building an engine that would be able to target anybody's mobile hardware could also be able to target their mobile hardware. Keep looking through here. How do you use an unbounded reference space with HoloLens 2? So the unbounded reference space that is basically just like you saw, right? Like kind of one of the first things you end up doing in an OpenXR application is you're going to set up that reference space that you want to use for your kind of base level tracking, right? If you were doing, we didn't show it here, but if you were doing, let's say like a room scale VR application, that base space you make might be the stage space, right? The stage space is the space that would, in your room represent the calibrated region that the user moved their controller around and defined as their region for doing room scale apps. And so if you get the stage space, y=0 is the floor. That's the place that you would stand to go do that. So it really depends what kind of app you're building, right? If you're building an app that just mostly is seated, then you could use the local space. That's great. Or if it's just standing, you're not moving around too much. If you want to use the room scale and put stuff on the floor, you would use stage space. And if you want to go on HoloLens and actually walk around a whole building or go outside, that would be the unbounded space that you would use. So really, it just comes down to when you're setting up that reference space, like you saw in the app, and then you're going to kind of ask, hey, where are the hands relative to the reference space? Where is the spatial anchor relative to that reference space? Where is the view each frame relative to that reference space? If you create that unbounded reference space, that's the key way that you would do that. Okay, go through here, just make sure we're not missing anything here. Oh, here's one. Will there be hand tracking on WinMR headsets with the existing tracking cameras? So, I mean, nothing to announce in particular about hand tracking, but the idea, one thing we are looking at is for controllers, right? One thing that Steam VR has today is an ability to have hand input, not just where the controller is, but an inferred hand around the controller. And as we were designing the hand API, this is one of those cases where everyone comes together and brings their best ideas. So Valve wanted to make sure that there would be a way that you could represent not just the natural state of the hand, but potentially, hey, if I'm holding a controller, what is, here is the state of my hand holding the controller, but what is kind of the social pose of the hand, closed as if the controller wasn't there, like so the user can actually make a fist rather than have that kind of contorted claw hand that represents what your hand is actually doing, even though you weren't really trying to do that. So we've left hooks. There's kind of an enum of what kind of hand you want, and we expect to in the future evolve that to be able to let apps request not just, hey, what is the true hand when you're getting hand joints from that extension, but also what is the social hand, or whatever we would ultimately decide to call it. So that would be a feature for inferring hand joints from somebody who's using a controller. I think your question was, would you use the tracking cameras to detect hands? And so there's nothing to say there, but definitely the intention of the hand joint API is to support that kind of full range of hardware, whether it's directly detected or it's inferred. Okay, let me look through here. So many questions. It's a good problem to have. And then also there's people posting about meetups doing VR, and so I'm going to publish those too. Okay, so come back out again here, take a look here at the questions we're publishing. And thanks for hanging in there as we're figuring out how best to do these kind of live Q&As remotely during this interesting time. Yeah, somebody was asking me while I'm scrolling through the full list again. Somebody was asking me, do I play Bedrock or Java in Minecraft? I put the Minecraft background because Minecraft and OpenXR and with Render Dragon. I have to admit, I'm a bit of a Minecraft noob, and so I actually have Java Minecraft from way back in the day, from like the alpha, and so I cashed in some code at some point when you could get the free Bedrock code for having Java. But I haven't played too much, but definitely kind of these days, especially with Render Dragon coming, I'm a Bedrock fan. I don't have enough mod investment to be to be tied to Java. Let's see here. What about Magic Leap support? So, I don't know if Magic Leap has announced anything or whatever. They're certainly an active participant in the OpenXR spec process. They've been helping us design things, including helping us make sure that the hand joints that we expose in OpenXR make sense for the Magic Leap the hand system that they have there. So so definitely they've been great participants when we're all building the spec together. But you'll have to ask them about Magic Leap support. Yeah, and it was mentioned that Monado recently added the OpenXR overlay extension. So if you're actually interested to see how an OpenXR runtime is built, Monado has an open source OpenXR runtime, and then they are using the OpenXR overlay extension there to help prove it out, right? To get exercise on it, so we can prove that it's something that works for overlay apps in OpenXR. Okay, I'm gonna do one more pass on the questions. I think we're 5 minutes from the end of the Q&A time. Yeah, and by the way, as somebody was mentioning, they had a late join. So this is a pretty dense presentation. So if you do want to kind of go through at your own pace and look through the kind of walkthrough that I did of the API, you can, as we talked about before, you can go just search for a basic XR app on GitHub. You can sync that project down. But if you want to just kind of go through this video again, it'll be posted online. I think they're posting event videos, but also the kind of individual talk videos are going to be posted as well. And just posted one more question. I think maybe this will be the last question. Somebody had asked, again, something we talked about before. Hey, will OpenXR replace MRTK v2? MRTK and OpenXR are great friends. They just work well together, right? They're different layers of the stack, and so the more devices support OpenXR, the less work that MRTK has to do, right? Because MRTK, supports Windows mixed reality, but they also support OpenVR headsets and all that, right? So they end up having to build various backends. It's better these days with Unity itself having an abstraction, the XR SDK abstraction, that helps unify some of that. But there's still edges where you have to punch around the side to get to more advanced capabilities. And it's just adds more work, right? On MRTK, it's more expensive to kind of keep MRTK up to date if the native APIs at the bottom are more divergent. Nick can attest to the cost of having to maintain that kind of stuff, but the benefit you get when you actually have one common API that lets you get access to a wide range of hardware. Hopefully MRTK can accelerate and actually move faster to add features because they just have less different backends to target underneath. Okay. Thank you all for coming. This was great. Please do follow up online if you have issues with basic XR app. Please file bugs. You can file pull requests. Anything you see there that should be better. And then there's also links on that aka.ms/OpenXR page. That page has links to participating in the OpenXR community. Kronos has a Slack for OpenXR, and so it's just great to see the community starting to build stuff. That's kind of where we're helping Blender get going and stuff like that. So being able to all build together is going to be wonderful to see, and I can't wait to see what you all build. All right, thank you.
All right. Thank you so much, Alex. That was really incredible. So I just want to just say, like, that information was fantastic. Like, you can't get that anywhere else. And honestly, like, I learned a few things about OpenXR, and I've been working on this stuff for like over a year. So that was amazing. Thank you so much. So in the meantime, we've got another break. We're going to be going for another 15 minutes. So take a moment, step away from your computer, do like jumping jacks or something, and we'll be back at 12:15, where Thomas and Raanan will be talking about building WebXR experiences with Babylon.js. So stick around, come back. We'll see you in a little bit. All right, welcome back, everybody. So we're back to building WebXR experiences with Babylon.js with Thomas and Raanan. So as before, while you're watching the video, make sure to think up of questions, and we have a QA box. So type in your questions and we'll get to them after the video. But Babylon.js is fantastic. If you haven't seen it before, you're going to really love this presentation. It is one of the fastest ways to do prototyping in mixed reality applications. So this is really cool. So without further ado, we're going to go into the presentation.
Hello everybody, I'm Thomas from the BabylonJS team, and today we're going to talk in our session about creating VR and AR experiences using web technologies. In particular, we're going to see how the combination of BabylonJS and WebXR makes it really easy to create those immersive experiences. So let's get right into it. And let's start talking about the first component, which is BabylonJS here. If we pause for a minute and we think about AR and VR, the first thing that comes into mind, one of the first thing at least, is 3D, right? And that's exactly where Babylon's come into place. It is a 3D rendering engine that sits on top of the WebGL layer, in the future also Web GPU. And that makes it much easier to create 3D experiences. It is not just a game engine, but not just a rendering engine, but a full feature game engine, right? So you'll find inside this API a lot of things like physics engine that have been integrated, animations, particle systems, all the good stuff that you'd expect in a state-of-the-art game engine on the web, right? Everything runs inside the browser. One of the key things also that is part of WebXR is the PBR, so physically based rendering, which is used in games, of course, but thinks also about e-commerce website and representing product in a very fine and realistic manner, right? Product configurators also on the web. All those are usage of BabylonJS. One key thing for the team is the notion of backward compatibility. When I was learning actually BabylonJS about a year ago, I just went online, looked up some old tutorials, I think they were like 3 years old, and to my surprise, this code that was 3 years old was working with the latest version. And we've all been stuck in those tutorials that don't work anymore, right? So this was for me the moment where I realized, oh, okay, it's really serious, the backward compatibility. And so that's something that is key for the team. And basically, you write your code, you will not have to go back on it again in the future, even if we keep updating all the time the engine. Another key thing is the support for this web format, the GLTF format for 3D objects. There is new extensions that comes all the time, and we work closely with the Kronos group to make sure to implement this into the Babylon engine. It's been used, it's pretty mature now, about 7 years old. You downloaded almost 3 million times on NPN. And of course, it is completely free and open source. Some of the things we have also on top of the rendering engine, the game engine itself, is a series of tools. Because we have in mind to make it really easy for you to go and create 3D experiences. So one of the first one that you see at the top right corner here is the playground, where on the one side, on the one hand, on the left, you have your code that you write in JavaScript, or can also be in TypeScript. And you see on the right, because everything is rendered in the browser, you see in real time what's being rendered. Another tool is the inspector in the middle. So in the inspector, you're going to drag and drop a 3D object, a GLTF file, for instance, and you're going to be able, or scene, a full scene, and you're going to be able to debug it in some way. So look at all the bones, the animations, the materials, the texture. You're going to be able to drill down and see what's wrong, if anything is. We're keeping adding more editors. So one of the last editor we added is the node material editor that you see at the bottom right corner there. think about being able to create shaders without writing code, and instead by combining little nodes and connecting them together. That's something that is very useful and common for technical artists, for instance. And finally, we also very recently added a particle editor, and that's just in the line of us adding more and more tools around specific features to make it easy and faster to create applications, 3D applications. I mentioned open source a little bit before. There is a very strong community behind Babylon.js, and you wouldn't be here if there was not this huge community that is on a daily basis active on the forum. So that's where you can ask any question if you're blocked, usually in 24 hours or much less. You'll have your someone will be taking care of you and helping you. Some people of the core team or some of the broader community. There has been about 300 contributors since the beginning that contributed some pieces of the framework. So thanks to them, we're here today. And yeah, it's a 7 years old API. So a lot of commits since then, of course. Pretty mature engine. I want also to talk about one of the last project we are a big endeavor we've been having for some time, which is Babylon Native. Let's pause for a minute and let's think of a dream we could have that is becoming reality, where you could take your JavaScript code and reuse it in a native application. So I'm talking about the rendering part, right? That you would take, think about an e-commerce website, for instance, where you would take the rendering part for the 3D object, the 3D scene, and you'd be able to reuse this in your native mobile application, for instance. And this could work also for some games. So that's what's behind Babylon Native project, which is available today in preview. It contains the full Babylon engine. So as we keep enhancing the engine and adding new capability, those will work also in the native applications. Recently, the team has been adding React Native, also a React Native integration to this Babylon Native. So even if you can choose your UI technology in Babylon Native, it can just be the whatever technology you have on a specific platform. You can also use React Native and have the same code again on the web and on your native application for the interface, for instance. And this is what's interesting is that it is bringing the fast iteration time you have usually on the web. It's bringing this fast iteration time also in the native application. And in some cases also, it's allowing to have much smaller package sizes. All right, so we're all at home watching our screen. So I was thinking that we could put a little energy here with a trailer. That's a trailer for our latest version that was released in February, and that explains, shows a little bit what the new features. So this is a current version that you're gonna see. Let's go right into it. All right. So you saw all the energy, all the passion that is behind this Babylon.js engine. And again, I want to thank the whole community that is behind it and that keeps every day adding new features. Quite a few of them were just done by exclusively the community. Let's change topic. Of course, it's complementary in this session. We're going to talk now about WebXR and talk a little bit of, I'm going to give you a little bit of background about WebXR for those who don't have. So it's an open API to create mixed reality experiences. So it's actually both now for VR and AR. It's a continuation of an older web standard, WebVR, who has now been deprecated. What it brings is a cross device. There is a community-driven controller repository which is going to allow basically a simple type of code that is going to be able to work across in an abstract manner across all the devices that are in this library. So it's very useful. The API is still stabilizing. The standard is still in draft, but it's pretty mature now. The previous one, WebVR, has been deprecated, really. So it's available in Chrome, in Edge, in Firefox, under Flag, in Oculus browser. So you can really use it now. Start using it now, testing it, using it, building first applications today to discover it. It is not yet supported on Safari and iOS. Hopefully, it will be soon. All right, so that's for WebXR. Let's talk now about BabylonJS and WebXR. And as Raanan Weber, who is the person behind the integration of WebXR in BabylonJS, as he was doing this, he had some key principles in mind that I'm going to share here. First, as always, the goal is to make things easy, right? So you're gonna see, right, the minimum amount of code to do the maximum, right? So that's something very important. Things have to work the same across all the device. So there's a little asterisk here. It means, of course, it depends on the capability of the device, but as long as there is a common ground, things should work the same. Mentioned at the beginning of the presentation, the backward compatibility. So again, it's still here, and we'll see how this has been implemented a bit later on. Rapid development, the standard is still in draft, so every week, sometimes every day, there are some changes, and Raanan is keeping the code up to date. And finally, I mentioned simple at the beginning, but one of our other core principle is to be powerful. So there is always room for advanced developers to go deeper. The native objects for WebXR are exposed, so you can go deeper and customize everything. Again, we'll see this a bit later, more in detail. What is available today is basically the latest version of the spec is implemented most of the time, very regular updates. Supports both VR, so virtual reality, and augmented reality scenes. Mentioned this object that every WebXR object have a corresponding object in Babylon.js, and there is a dynamic button to enter and to enter and exit AR, so you can customize this here. One of the key things also is Raanan created a simple to use experience helper. So basically we'll see how in a single line of code you can enable WebXR, you can enable XR, basically a VR in your scene. We'll see this in a little demo, some demos I'll do at the end. Something else that is present is a feature manager. So think of it as a plugin system, right? That is make you pick and choose what feature you want to use of WebXR. So it's useful firstly for versioning. I was mentioning backward compatibility a little bit earlier. That's how it's implemented. So there is a module, let's say for gaze or hand tracking, there is a module that is implementing today hand tracking. Well, in the future, if the draft is changing, there'll be another module, right? So that's how we can keep the old one always compatible, backward compatible. Another very good aspect of this feature manager that I was mentioning a little bit before is that as a developer, you may not want to use everything, right? So you're going to be able to load and use the features you want to use in your code. And finally, for those advanced developers, they can customize. So they can create their own plugins, and they can also actually contribute to this plugin system. User input. So there is a native support for the WebXR input profile library that I was mentioning at the beginning, with a fallback system depending on the capabilities of each device. There is a pointer selection feature for cross-device support, which means basically that with one single code, you're going to be able to select with the mouse, with the touch, with gaze, with controller, right? So if I take an example, a trigger on the controller is abstracted into a pointer event. So that's how it's allowing us to have just one single way to access this, to select, for instance. Gaze, you know how on some of the device there is no controller, so to be able to interact is just fixing, looking at an area for a specific moment of time. So this is there. It's called delay selection mode. The gaze and the hand tracking that is also coming is of course an input. Teleportation, very important in VR to avoid motion sickness. So that's how you can go from one point to another. So this has been implemented. There is all kind of advanced features there. You can rotate, you can move backward. You can also customize, not customize, you can enable some zone where people can, you want your user to land, right? You may want them to go just to specific places of your scene, not everywhere. And again, it is fully customizable. Physics. So this is not part of WebXR per se. That's something that has been added on top of it in its implementation in Babylon.js. And this is because with your hand, with the controllers, you're going to want to interact with the 3D scenes. So that's why we added this physics engine. So both the hands, the head are a physical object. So we can move and we can move object, we can hold object. Again, it's fully customizable, and there's a few demos. I'll go over some of them at the end of this video. Another part is the augmented reality AR. So it's supposed it's supported in HoloLens 2 with the Firefox reality browser. In terms of features, there is the heat testing, there is plane detection. You can see on the right here, and this is for now available just on Android. There is a feature manager, so they're available behind this feature manager that I was mentioning before. So you can just load some of those specific features. Right now they're behind a flag. And another feature is the background remover. Think about if you have a scene, if you have an experience that is being used both in AR and in VR. When you're going to be in AR, you're going to want to be able to see the world around you. So there is some meshes, some 3D objects that you're going to want to hide when you are in VR, and that's what you can do with this background remover. The skybox typically, so what's around can be removed or not displayed. What's coming? In very short term is the first final version of the hand tracking that Raanan is working on. There is also still a few issues on our GitHub, so we're keeping working on this. Some teleportation improvements, some light estimations, and also Babylon native support of WebXR. So I was mentioning before how with Babylon native you're going to be able to take your rendering code that you did for the web and be able to use this also in your native applications. And of course you can just do a native application but using those web technology. So the team is implementing WebXR using OpenXR interface once it's available on the native platforms. And for iOS and for Android, because OpenXR isn't ready yet, they are using AR Core and ARKit. All right, a lot of talk, a lot of slides. Let's take some time to do some demos. I'm just gonna look if I have enough time. I do have enough time. So let's go right into the demos. I'm gonna switch here. And we're gonna start, and I'm gonna hide my face here. So this is a documentation. I just wanted to highlight that everything is documented. So you just go on Google and WebXR, Babylon.js, you're gonna land on this, and you're gonna find a lot of documentation, a lot of how-tos, a lot of examples for you to understand what is a WebXR, for you to start experimenting with it. See a lot of content, and in particular, you have a section with demo and with examples. So each little code here is actually an example, some basic one, some more complex one. And I'm going to show two examples. Let's start with the first one. So this one, let me start by explaining what you see on the screen first. So I was mentioning one of our tools, which is the playground. So on the left, you see the code. And on the right here, or in the middle, actually, you see what's being rendered, right? So what the user is seeing. And this is in live, of course. Everything is in the browser. This scene is basically one big 3D scene inside a file. So this file is being loaded here. And I was mentioning the helper a little bit before in the presentation. You're gonna see that just with this line here, that's the only line that is needed to enable the immersive application. So because there is this line, which is basically enabling the session, doing the session, the WebXR session initialization, managing the input sources, the camera, teleportation, scene interaction. You can just go in immersive mode here. So I'm clicking here, and so you can understand on this right here, you see the developer tools. You see what is called the WebXR emulator, so that you can install as a plugin, and then you can emulate a device. And I pick up here Oculus. There is different devices that are available for you to test. And if I select the headset, so think that if it's like if I would be moving my head in the headset, and you're gonna see that the view is changing basically. So basically one line of code to enable, to transform, to make this scene actually a full VR experience in this case. Let's go to another example that involves physics. And that's a simple, quick demo that Raanan did about a goalkeeper. So let's sit back a little bit. You see the goal here. And imagine that I'm in front of this goal and that I'm going to have some balls thrown at me. And when I have a headset, I would be with the controllers, or with my head, I would be trying to block the balls coming. So again, I'm going to immersive mode here. You see the two controllers, and you see what I'm seeing with the headset. So I'm going to unselect the headset here. And on the right controller, I'm going to see it's pointing right now to the easy mode. So I'm gonna start the game. So balls are gonna come at me. And then I'm gonna pick this controller, and the goal is to be able to block some balls. And yeah, it's hard to talk. And okay, I got one. You see an example, right? So what you see here is physics, basically how the controller is interacting with the ball, and that's the goal of the example. So I can stop the game here. And if we look what it means in terms of code, we take some time to look at this. There is, again, not much lines written purely for the XR piece. So in this example, everything is created inside the code, so it's not like we're loading a scene. So the lights are being defined here, the environment, the shadow engine, the GUID, you see this little button where you can click. So all this is just a 3D experience written in code in Babylon.js here, directly into the playground. So nothing XR related in some ways. The XR really starts at this line here, with this line, one line where I'm calling the helper, where Raanan, who wrote this demo, is calling the helper and again creating everything for you, right? So one line to create everything for you. It's not enough in these examples because remember we want to interact, right, with the ball, so we need some physics there. So what it's doing is here actually is just adding some shadows. So in the scene, if you look, there is a shadow of the controller, so it's adding the shadows. And then to actually call the physics, so how you can interact with the ball that are being thrown at you, is using the feature manager. Remember this plugin system where you can just pick and choose what feature of WebXR you want. So it's calling it here, instantiating it here, and then calling, getting the physics, enabling the physics. And that's pretty much it, because the rest of the code is inside the XR loop is the code for throwing the balls every 2 seconds. So that's not really XR related. And then that's it. So conclusion, pretty simple to write VR and AR application. We can do some other demo with AR another time. This concludes the demo. It also concludes our presentation. I hope you got all pumped up with the possibilities of those technology, and maybe you already have some ideas on how you're going to use this in your applications. I want to thank Raanan Weber, who created, was behind the integration of WebXR into Babylon.js, and also I want to say thank you for watching this video. We're going to be live in a Q&A, and I'm trying to find the right place here. Yeah, we're going to be live now in a Q&A to answer your questions. So Raanan is gonna join me right after this session. Bye now, and stay safe. Bye-bye.
All right. So thanks for watching the video. I hope you got some useful information in it. We're going to jump now to the Q&A, like I was saying in the recording in some ways. And I'll start with some very introductory question. Someone asked, how do we get started with Babylon.js? I would say, because I was there basically a year ago, one of the first things I did was to jump into the documentation. There is a really detailed 101 that you can jump if you're already used to 3D, but there is a lot of details and a lot of notions that are explained there, along with some very detailed examples and what we have in the playground. So you'll see not just the theory, but also a lot of code and a lot of examples, and you can see the difference right away. So 101 documentation, Google Babylon.js documentation, you'll land on it. We also have a YouTube video channel, same thing on YouTube, and you'll see some of the member of the team, in particular Pyra GC and Patrick, our tech artist, who do weekly videos explaining you some key parts, some of the latest features, and walk you through demos. And some other interesting things also, if you really are a beginner, is to do some MOOCs, so online course, basically. So I went myself to Udemy. I think there's a couple courses there. They were very well done. One a simple one and one very long, about 10 hours, that goes through the whole process to create a game. Those are actually maybe a few years old, but like I was saying, it's still working today. So it's a good place to start. Let's look for some other questions. There was some question asking, here's the question. So using WebXR plus Babylon.js plus some 3D web library like 3JS allows for building full mobile AR experiences with pose detection and space. without needing Unity or Unreal? So the answer is yes. Babylon.js is a 3D engine, so you don't need anything else basically to create your application. It's a full engine, so you also have some physics. If you need particle systems, you have everything there to create on the web, right? So JavaScript. Now, if you want to do a mobile application, you can use a web view, for instance. So you can have this also on your mobile application. And if you want to have this run natively, that's when comes into place Babylon Native that I was mentioning, which is in preview. So in this case, you'll take your code, your JavaScript code, Babylon.js JavaScript code, and you'll have it run natively. So it's not yet available. You can preview it, start testing it. It will be available, I would say, in the next semester. Some other question here. So very pragmatic question. Are there feature behind paywall, or how do you cover for company overhead? Because some of the core team members are part of Microsoft. So the answer is no. It's 100% open and 100% free. There is nothing behind a firewall. I think there is two reasons there. The main one is overall at Microsoft, it's a new, things have changed a lot. I've been there for some time, but things have changed a lot. And now it's actually strongly encouraged for developers and members of Microsoft to be active and contribute to open source. So there is absolutely no worry for this. Everything is and will remain free and open. It's actually not even strictly per se a Microsoft open source project if you look on the repo. So it's a pure open source project. It's not under the Microsoft organization, to be precise. Let's go to maybe some more technical question, and I will ask Raanan to jump in there. He'll be much better at answering some of those questions. I don't know, Raanan, if you want to pick one up, or I can just pick you up.
I'll pick one up.
Yeah.
I'll start with the first question I see, which is there any published comprehensive comparison between WebXR and OpenXR? And not that I know, there is no page that shows the differences between them, but WebXR is actually a small set of the OpenXR features. So under the hood, it is using OpenXR. The browser itself is using OpenXR, just like Alex said in the presentation before us. So eventually, hopefully, all of OpenXR features will be available in WebXR, but there is no comparison that I can show. There is a question about the multiplayer support for Babylon.js. Babylon.js itself does not support multiplayer per se, but since we are in the web, we can use any game server that is available. So we have in the community, in the forum, you would find a lot of examples of people either implementing their own socket servers or using some other frameworks to achieve multiplayer support. And there are wonderful examples that you can check. And there is multiplayer support on the web, but not integrated in Babylon.js. There was a question about performance and size and poly count. There is no limitation poly count. It's all about the performance of your application. In XR and VR, it's very important to keep the performance to keep the frames as high as possible. So you will want to not use amazingly complex objects, but there is no actual limitation. It depends on the scene that you're implementing. It depends on the amount of objects that is currently being viewed. It depends on many, many factors, but there is no actual limitation. Let me see. Let me find questions that were not answered. There's a question about proprietary code, which is always somehow a problem on the web. Since we are on the web, everything is downloaded and everything is shown to the user. There is no real way of hiding code. You can minify your code, but eventually the code can be seen. There is also no way of hiding your models in any form of encryption, because eventually it needs to be decrypted on the user's side. For that, I would use native apps, or Babylon native, for example, that will be able to hide those things from the user. But on the web, it's relatively hard to encrypt and not show the decryption to the user. A few new questions. I will try them. There is a question about Babylon native and whether or not you can use Babylon native with other 3D engines. Babylon native is written with Babylon under the hood. So it's not only WebGL, it's actually Babylon. So you will probably not be able to integrate a different engine. It's Babylon under the hood. Sorry, I got disconnected for a second. Don't see any other questions. If anyone has any question, please.
Yeah,
write them down.
I saw what I just published one that is
I see.
does it work on Mac or only PC? And the answer is it works on Mac and PC and mobile and all kind of device, as long as there is a web browser. Basically, it's gonna work. It relies on a standard, which is WebGL, which is available on I think some of the last numbers is 98% of the web sessions that you have. So all kind of device, even some old feature phones would work. It's also an occasion for me to mention that this mature engine of Babylon has a lot of fallback system. So it's going to try to use the best and the latest feature of WebGL2 extension. And then if it doesn't have it, there'll be a fallback and then a WebGL1 fallback. So it's how basically we're entering and we have done all the legwork of ensuring this cross compatibility. So no worries for this. So that's for the web part. Now talking about the Babylon native part. So when your code is going to run natively on different platform, it's also not limited to PC. There is today some preview version for Android, for iOS, for macOS, for Windows, of course, for HoloLens. So we keep adding more platforms. So funny to see my headset appear and disappear. That's the magic of the algorithm here. Let's see some other questions. There was some question on the object file size for WebXR. Raanan, I don't know if you got to this one. Any advice on object file size for WebXR? Is it limited to browser hardware? Yeah. Okay. Okay. So I don't see any new question.
There is a question about the similarity to 3JS and to A-Frame.js. Those two questions were just presented. BabylonJS is another WebGL engine. Though they are working with the same technology, but doing things a bit differently. Each one has its own strengths and weaknesses. I would recommend to always try them and see what's more comfortable for you. I'm very biased, I know, but I find BabylonJS the simplest to use. But it also depends on the use case and it depends on what you want to achieve. We are trying to get everything we can developed and everything available, but sometimes we have things that other frameworks don't have and other way around. So it's all a matter of choosing the right framework for you, and we very much hope that you will choose BabylonJS. And let me see if there are any other questions.
Yeah, there is a question about React Native. So the question is, there is a React Native package. Do you know if all capabilities are available within that package? So honestly, I cannot answer in detail to this question, but for me, it's the occasion to point you to the content and to explain a little bit this latest initiative. So it's basically for Babylon Native for the UI part, right? So you're in your native application. You want to have the 3D rendering part, and you're thinking about the UI. So you have several possibilities. Firstly, there is in the framework itself, in the BabylonJS framework itself, there is already some UI capability. So some 3D UI, some buttons that you saw there. So you have some basically GUI application, GUI capability. Second, you can use any native UI technology, right? And if you want to go web and go React Native, that's been one of the big work done by some other team, actually at Microsoft. So Raanan and Alex, to mention them, who spent quite some time on this. And what they have done is basically integrating React Native with Babylon. And what I'm going to do is I'm going to point you an article on this, on the link there, and you'll be able to understand the choices they made, where they are, and you can deep dive on the GitHub exactly for the details of your question. I don't know, Raanan, if you know more than me on this, but I just wanted to start giving some elements of answer here.
It's a wonderful answer. And there is a question about if you need to be device conscious. We try to abstract as much as possible. So we try to provide you with the ability to create one single code base for all devices. Sometimes we need to be device specific. If, for example, a certain controller of a certain device has a button that the others don't have, and you do want to use it, then you as a developer will have to decide that you want to write this specific part of the code for this specific device. But in general, we try to always keep all code that we write as abstract as possible. So yes and no. You can be device conscious, and you can implement for a specific device, but you don't have to.
So there is a question with which is the following that I just published. Could we use this library with Amazon Sumerian? And the answer is yes. Actually, the team from Amazon, from Sumerian, reached out to us. They've been doing some PR. So you can use this avatar, Sumerian avatars, also in Babylon. So the answer is yes. Also, I add a link in there. See if anything new keep popping the question up. I think nothing new is coming. All right, going once, going twice. Raanan, you good?
I'm good if everyone else is.
Okay. All right. Oh, well, thank you for taking the time. We start at 9 a.m. at least on the West Coast here. It's now 1 p.m. So I hope you got some break. We're gonna give you some time here also to do a little bit longer break. I hope you, as I was saying, got excited. There is so much passion in this team when I joined it 1 year ago. So I hope you feel this. And if I have one call to action is when you get into Babylon.js and WebXR, reach out to us. Come to the forum. You'll see. You'll have an answer to your question. We'll reach out to you in less than 24 hours. The community, but also the core team, basically people in my team, every day one of us is there and making sure all the questions are answered. Sometimes we don't have the answer right away, but we make sure to follow up. And one of the key things is also when it's a bug, we try to fix it as fast as possible. And overall, our time to fix the bugs is less than 24 hours. With that said, have a good afternoon or day, depending on when you are, and have a good break. Nick, back to you.
All right. Thank you so much. That was a really excellent presentation, and I enjoyed it quite a bit. Babylon.js is a lot of fun, and it's really cool to see it in action. So we have another little break here at 1:30 p.m. We will be having a couple of nice guests. The team from HP has come by to give a presentation about their brand new headset, the HP Reverb G2. It's a really fantastic device, and you'll get to hear about it from them. A lot of really interesting details. So stick around. We're going to take a break. It's about half an hour, and be back here at 1:30. So enjoy, take a breather, and we'll see you soon. All right, everybody, welcome back. So now we've got to the final presentation for the evening, and it is definitely a last, but not least. So this is breaking down the HP Reverb G2 by Peterson and John Ludwig. So they'll be around after the presentation to answer all of your questions. So without further ado, let's get into this delightful video.
Hey everybody, welcome. My name's Peterson, head of XR software at HP. Today I'm really excited to bring you the HP Reverb G2 as we go into a lot of the details around the G2 and what makes it special for you as a VR developer. The G2 really builds upon the success of the original HP Reverb. The original HP Reverb, we focused on visual acuity, lightness, and a good price point for people to get an ultimate VR experience. With the G2, we listened to you as a developer and also the user of VR and incorporated your feedback to some really key areas to improve. We also brought on a new partner. We also brought Valve. So this device was built with the collaboration of HP, Microsoft, and Valve together in order to really push the envelope of VR. The displays are the same resolution, 2160 by 2160 squared per eye, so that's over 2K pixels per eye. We are using a different display compared to the G1, so with improved color accuracy and brightness. This is absolutely perceived the minute you put on the G2. Gone are some of the Mura issues that we saw on the G1. So the immersion quality of the device is phenomenal. Now, with that, you still need high quality lenses. The G1 had extremely high quality lenses, but we've gone a step further with the G2. We partnered with Valve and we came up with a new lens design. And that lens design has increased a larger sweet spot in the lens and really brought those displays to light. This is one of the most premier VR experiences. Windows Mixed Reality allows us as developers to basically bring VR to everybody. Not only can we write applications in VR that are specific for Windows Mixed Reality, but we can also take advantage of the large Steam ecosystem of games that already exist for virtual reality. People were blown away when they saw how great the HP Reverb was from its optical quality. The G2 takes that and turns it up. So today, I want to talk about some of the key features of the G2 and why we made those decisions, and what does that do for you as a developer and also as a VR content user, and what that means for your experience. So we'll dive into the new features, including the 4-camera tracking, our new controllers, our displays, optics, and IPD adjustments. We have a new headband with a 90-degree feature that allows you as a developer to go in and out of the device very quickly, and our new cable, which basically allows you to have a larger play space as a VR user and as a VR developer and enthusiast. So let's get started. So let's go get a quick rundown on the specs of the HP Reverb G2. So we start with our panels. They are LCD and 2160 by 2160. We're using a different LCD panel from the G1 with improved quality, color accuracy, persistence, and brightness. Gone are some of the issues we've seen with Mura. This is a very, very high quality panel. And coupled with that panel is a lens that we developed with our new partner, Valve. This product was developed not only with HP and Microsoft, but also with Valve. Us three together really took the VR experience to another level. These displays are being refreshed at 90 Hertz, just like the old G1. 90 Hertz seems to be the industry standard for making sure that we have a very immersive experience. I know some other headsets actually use a higher refresh rate, but we found during our testing that 90 is just fine and completely adequate in order to make sure that people are immersed in the experience, so people don't suffer from any motion sickness while using the VR HMD. The device is still very light, coming in at around 1.1 pounds. Certainly is one of the lighter devices out on the market. So it's very comfortable for you as a user and as a developer to use for extended periods of your day. I have many developers on my team who use the Reverb G1 and G2 now for their development activities. And some of those development activities are not necessarily in VR. The visual quality is so good that they can read the text directly on the screen in front of them in Visual Studio or in other text editors. So it is a phenomenal device for productivity. Speaking of productivity, the fact that the headband, which is we are calling the sort of the 90-degree feature of the headband, does allow it to flip up. Now, when it does allow it to flip up, it pushes it out of the way, and I'll show you here on camera. And if you push it out of the way, it makes it very easy for you as a developer to quickly go in and out of VR by bringing it up to your face in a way. I can't tell you how many times this is extremely important while you're trying to check visual, visual, you're seeing, how good things look. And so a lot of times we'll have developers that actually have these sitting on their desk just like this and just be able to go in and out of VR. So productivity is amazing in this device. And as a developer, you're going to find it to be probably the device you want to have while doing VR development. As we're sort of focused on the device itself and some of the specs around it and in the headband, you've obviously seen the new speakers that we have, or the headphones, right? These were co-developed by Valve. These are very similar to what exists on the Index. The audio quality of these is phenomenal. I'm definitely somebody that is interested in high audio fidelity, and this is a fantastic device for that. Over the ear is obviously has a ton of benefits, and you do not lose any immersion capabilities by having an over-the-ear design. It blocks out still quite a bit of your ambient noise and surrounding, really bringing you in to the immersion of whatever VR experience you're using. Probably one of the most anticipated features and best features of our new HMD is 4-camera tracking, right? And as you can see the exploded diagram behind me, you can see 2 cameras on the front of the device, but we've added 2 cameras on the side. This is very important. This improves our tracking volume by a significant amount. So Windows Mixed Reality Tracking, if you're not already familiar, is an optical-based solution. So when the controller is powered up, there are visible light LEDs that those cameras do pick up. And so with the G1, with those cameras mostly facing forward, there was a point in time where as the controller did move outside of your tracking range, you could lose it. And for certain experiences, this could create some issues, right? Now with our side cameras, we have a tracking volume that is greater than any of the camera tracked systems, or on par with the camera tracked systems, right? And so game experiences and experiences that require your hand to be potentially out of your field of view and around the side of your head are now trackable. So this was one of the biggest complaints about the G1. And certainly we've addressed this. We've listened to the feedback of users and developers who are building for the Windows Mixed Reality platform and decided this was a key feature we needed to bring in. And still, all this computer vision and tracking is still done on the host system. So the device itself is actually not processing any of that tracking information. We're sending those camera feeds all the way down to the host PC for Windows Mixed Reality to process that data. We have plenty of bandwidth still left to do that, and the host system is not taxed at all above and beyond what it needs to do for VR. So we have an improved optical system. We have improved 4-camera tracking, but let's talk about these controllers. These are brand new controllers. So gone are the original mixed reality controller with the thumbstick and also the pad. And what we did bring is a more simpler design that is in line with the industry standards of controllers today. It's more ergonomic and positions very well in your hand. The buttons are laid out A, B, X, Y on both controllers, on the left and right controllers. There is a trigger in front and a grip. Now, One of the most important things about this controller is this trigger. This trigger is no longer digital. This is no longer press and it's only a 0 or 1. This is an analog trigger. So depending on how much I press, I can actually read that value inside of my application. This is really important for immersive experiences that require hand control, right? Where you might map that trigger input to the opening and the closing of the hand at a variable rate. So as a user gently presses down the trigger, maybe the hand closes a little bit more. This is very important for us at HP because we look at our devices not only as devices that can bring the highest quality VR to consumers, but also to commercial users who want to use VR for very specific applications. VR is extremely important in the commercial space for training. And so training, there's a lot of applications where you're simulating an environment. And that environment might be you as a person doing some sort of repetitive task and trying to learn it. So that might be you picking something up, moving something. We certainly have training in the medical space, right? It might be you picking up some tools and handing it to a doctor. It could be you doing some OSHA training and making sure you're placing things in the right space. So really, simulating more natural movements with the controller is extremely important to us. And I believe that this controller really brings the experience even further ahead than it's ever been. So we're really excited about this. We're really excited about the analog trigger. Obviously, gamers love this idea because there's all sorts of game and gameplay that can utilize even more, of the analog trigger and the buttons. I mean, these buttons are basically, they have very nice positive feedback. They click, you can probably hear it. They just feel really good in your hand. This thing just generally fits good in my hand. I maybe have a medium to larger size hand, but even we've tested this with people with smaller hands. Fits very well, no fatigue while holding it for extended periods of time. It still comes with the lanyard, which basically can be attached to your wrist and make sure that you're not throwing the thing across the room if you accidentally let go. And we're still powering these devices by two AA batteries. Now, obviously, these AA batteries can be either alkaline or, some for higher use situations. We're looking into the option of, using AA rechargeable batteries inside of there. But overall, this controller, this is a big step forward for Windows Mixed Reality and for the HP Reverb G2. So we're extremely excited about it. Now, as a developer, you've already written some applications already for the HP Reverb G1, and you're wondering how you're going to be porting your application over to using the new HP Reverb G2. And so there will be a new button profile that will roll out in order to make sure that you can take advantage of the different buttons, right? And the fact that we do have the analog trigger. But what we found with a lot of developers is they weren't using the full capabilities of the original controller, right? So they were either using the joystick or the pad, right? But really, it would be very complex for a user to master all those controls in a single case. So a lot of interactivity in applications was around either one or the other. And this was the primary device to use to move a user or quote teleport the user around in a VR environment. So we really honed in on what are the key controls that you do need in order to have a premium sort of VR and immersive experience. We still do have the Windows key down here, right? So you can get your menu up on the screen, right? And we do have the contextual menu key as well, right? So they are down here, they are recessed, so they are not accidentally activated as you're pressing the buttons. The A and B button are raised, right? And your thumb just sort of naturally goes over to them. So overall, great new controller. As a developer, you're really going to like putting your applications and mapping to these types of controllers. Obviously, this is going to look very, very familiar to you from other competitors that have controllers that look this way, and so sort of the industry is moving this direction towards this type of controller. Going back to the HMD. One of the other things about the optical path of the HMD was, we did a lot of work in order to make sure that there was a really good sweet spot in Reverb G1 with the lenses and the optical path. But we did hear some feedback from our users and our developers that there wasn't enough range. And so what we did do is we did add a mechanical IPD adjustment to the G2. So this little slider at the bottom here, what it does is it actually does move the lenses in and out mechanically, so you can see that. It also reports the value directly to the operating system in Windows Mixed Reality. So as you're moving this slider, you'll see an indication on the screen of what you're actually setting your IPD to. This is important for numerous reasons. Number one, if you're a user and you're coming back to maybe this is not your HMD, you might be in an environment where you're sharing one. You might want to understand what that optimal setting is and come back to it very quickly, right? So it's like, okay, I'm 62, I need to adjust it for 62. And so you can do that very fast. Number two with that is that there also is, custom calibration that happens. We don't just move the lenses out, right? You actually have to take into account and transform that the actual images that are being rendered just ever so slightly as you move the mechanical IPD adjustment. So that is taken into account, reported back to Windows Mixed Reality, and those adjustments are made. Just like that software IPD slider that exists in Windows Mixed Reality today for devices that don't have a mechanical IPD adjustment, that slider actually does affect the images in the display. It does do a virtual shift and of those images. And so this will work in concert with that in order to provide a really clean, crisp image for you if your IPD is sort of outside what we would consider sort of that sweet spot, that normal range. So really critical feature as a developer, especially if you're building an environment that's going to be targeting users of potentially any IPD range, right? You want to be able to put this and make it really exist on a device that's going to be able to support those users. So really excited about this. Key thing here too with the face gasket, it is magnetic, so it pops in and out very quickly. I really like this. And so this is a cloth one right here, but we do have a sort of a fake leather one as well, which is sanitizable, which is really important for commercial customers that are moving potentially multiple people through a VR experience in a short amount of time. This is obviously very important today in the situations that we're in today. So obviously for personal use, cloth, it's very comfortable, very nice in the face. Allows you to operate the device for a long extended period of time. The leather gasket feels great as well. So, the device I have here is obviously cloth, and that comes integrated with the nose pad. Overall, from an immersion standpoint, I love this device because it blocks so much light out. And that's so important in immersion. Obviously, I work in a home office like most of you do today, but in my home office, I do have, during the day, I have a lot of ambient light around me. And so if I'm going in and out of VR, I want to make sure that that ambient light is cut out, right? And this design basically takes care of that for us in a great way. Now, one feature that really isn't talked about a lot in sort of VR devices from a spec standpoint is how it's tethered or how it's cabled. Remember, HP Reverb G2 is a host-tethered VR HMD, right? It connects to your PC running Windows Mixed Reality, which means there's a cable involved, right? I mean, we have a cable coming off the back of it here. Now, keen users of G1 will realize very quickly that this cable is much smaller in diameter, and it's also much more pliable and malleable. This was really important because in G1, we're really pushing the limit of pixels and connectivity and making sure that we can have extremely high quality signals going to this device. This, like I stated earlier, is over 2K pixels per eye. That together plus the USB traffic that's going on with this device is really starting to push the electrical limitations of DisplayPort and USB together. And so from a cabling standpoint, there's a lot of engineering that goes on here. And one of the feedback items we heard is that cable we used to have was pretty heavy, right? And it was pretty stiff, and it could pull down on the device and really start to change the experience that you might be having with the device. And so we spent a lot of time engineering a new cable, right? And so this cable right here has all the high-speed interconnect for DisplayPort plus USB in now a 6-meter length. So 6 meters is greater than the original cable. Now, with that, we did have to make a couple changes to it. So one, what we did do is we took the connector that used to be on the outside of the device, which sometimes may have come unplugged with very sort of hard force in G1, and we changed that connector and we moved it right into the front of the unit. So you have to take off the face gasket, and then you'll see the connector is plugged in right here. There is no little pigtail. It plugs directly straight into the board right on top here, right? There is no way that this thing is coming out if you start tugging on the back of it. The other thing here is that there's a cable retention right on the back, and this keeps the cable in a very good location, towards the back of the user, right, as they're moving around with the cable attached. So overall, the cable feels a lot less intrusive, which really doesn't break your immersion experience a lot. Now, the other thing is on the end of this cable, we've changed the connector type. So we still have DisplayPort, which is absolutely required in order for us to push the number of pixels we're trying to get to these displays at the refresh rate we're doing. But we also changed from USB-A to a USB-C. And so most modern PCs are going to have USB-C available on their system. This is a USB 3.1 device, right? And also with a USB-C type connector. Now for the 6-meter cable, we are requiring an external power box, which is connected to the cable, which is at the end of the cable. And it requires a plug into the wall. So just kind of think like a small laptop adapter. Now this really helps us because it gives us that extra power we need to drive those backlights, to lower the persistence on the displays, to really provide that amazing immersive experience without having to have a compatibility problem with other systems that might not be able to drive that type of power out of their USB-C ports. So we'll definitely provide that. That comes all in box, right? So you get the 6-meter cable, you get the power plug, right? Plus the USB, the cable with USB-C. We're also going to be dropping in a box the USB-C to USB-A connector for systems that don't necessarily have USB-C. That's really important for you as developers. You're targeting other systems as well. You might not know that these people actually have a system with USB-C, but trust us, also building very premium PCs and looking towards the future of PC and sort of graphics, we do see a trend towards more systems providing USB-C connectivity in this case. So anyway, so the cable itself, extremely well engineered. We really did focus on it in order to provide a greater experience. Now, for some keen folks that realize that we do have another system, we have what we call the VR backpack PC. We will be offering a shorter, what we call 1-meter cable that does connect directly to the backpack to the HMD, so you do not have to deal with 6 meters of cable if everything's connected to you. Now, that will not have an external power port because the backpack PC will be able to deliver the correct amount of power to the device in order to make sure that we can power it and all the systems are working great. So overall, lots of great improvements from the hardware perspective. As a developer, you should be really excited about the overall, the controller and the tracking volume, and just sort of generally how well accepted the device is going to be amongst sort of the ecosystem of devices out there right now. So that really covers sort of the general specifications and differences between HP Reverb G1 and G2. And so I really wanted to get into some of the other things that you might be interested in as a developer, as you're looking at Windows Mixed Reality and just generally the HP Reverb G2. We get a lot of questions, and we have had a lot of questions by individuals. And really, some of the things revolve around, how fast, how powerful my PC needs to be in order to do this. Can I use other tracking systems? Do I have to use these controllers, right? Do I need, could I use some other integrated systems, right? And so, sort of starting off with that, right? What are the minimum specifications to run HP Reverb G2? And so just like I stated, we're pushing a lot of pixels, right? 2160 by 2160 per eye. And really starting to extend the limitations of the current DisplayPort standards, and really requires a graphics card that can do that. We at HP have been focused a lot on the NVIDIA line of NVIDIA GeForce line of graphics cards as we start to size up VR systems. And with G1, we really did state that we would like to see users with a 1080 at the minimum, right, to be able to power this experience. Now, obviously, since G1's come out, we've seen the Turing level of cards, so the 2000 series of cards come out, and there really isn't some people will say there's a direct comparison between the 1000 series versus the 2000 series card, and so I think it really depends on the type of experience you're trying to deliver. There is a feature in the G2 where we do have a display scaler inside of the unit itself. And so we will drive all those pixels on the display, but we can operate in what we call half resolution mode. So we can actually drive half the number of pixels to the display. Now, obviously, the visual fidelity and acuity is going to drop. Your optical path, though, is not going to change, right? So those clear optics from the lens all the way to the panels are going to be the same. But the number of pixels you're actually driving to the display can go down. So this is important for systems that might not be able to drive all over those 2K per eye number of pixels. And so Windows, Mixed Reality, and Microsoft, we've worked together really to make sure that that option is available, and the device sort of seamlessly supports that as we're working, as users basically bring these to their systems and effectively plug them in. So we still have the same sort of minimum requirements as we say what the experience should be. But it really varies system per system because, like I said, the VR, as a VR developer, what am I doing with my actual environment really changes, right? How much of the CPU am I taxing? Obviously VR is very, very GPU intensive, right? And that's why we require these really high-end video cards in order to make sure to provide a premium experience. But there is a lot of CPU taxing going on as well, right? And that will vary depending on the type of experience that you're actually into. There are some games and some simulations and even some training experiences that can really bring the CPU up, and be using both at the same time. And it also depends on the what we call the game engine, right, or the VR rendering engine that you're using in order to build that experience is going to take advantage of different resources on the system. So overall, what we do say is that we are pushing, sort of the upper third of graphics and expectations of graphics cards. And we're working with, as we interact with our development community and as we put out specifications, making sure that it's very clear what graphics cards provide that premium experience, right? Now, one of the other ones I saw, which I thought was actually really cool as well, and it came out as one of the reviewers that got early hands on the HP Reverb G2, is that they used the Knuckles controllers with the Reverb G2. So everyone that doesn't know, the Knuckles controller is a Valve based controller that's sold with their Index. It uses the overhead tracking system, and it does have a unique experience as it slips onto your hand, and it can read sort of individual sort of finger motions, right, as you're in certain experiences. And it's really cool in certain games, and I've seen stuff even in simulations where you can kind of have your hands out and start moving it around, and that's really important. But pairing two separate tracking systems together can be very complex. So there's a video out there today, and probably some of you have seen it, where they take a Reverb G2 as the visual device, and basically the Knuckles controller plus overhead tracking system as the input device. Now that requires you to combine the tracking system. So there is a way in Steam VR in order to do that, and there was a holding the controller and making sure both are in the same hand and sort of moving it around. But there are challenges to this, right? You were talking about two separate disparate coordinate systems in 3D space, right? And so a quick lesson on, how this stuff works is that those cameras that are in front of the HMD, they're looking out in your space constantly, right? They're mapping it and figuring out all the little contours that are around you and building a 3D mesh, basically, of where you are at, right? Now, that's all coupled with an IMU in order to really give the transform and capabilities and the 6 degrees of freedom that we're used to. Now, the sort of valve tracking system is based on different technologies. It's not based on a camera system. It's based on stationary beacons feeding information back to the devices. Now, while some people might say one is better than the other, that's not what we're looking at today. We're looking at how do you combine 2 coordinate systems together and make sure they play in the same space. So with the stationary tracking systems, the coordinate systems tend not to change very much. Because of the stationary nature of the beacons versus what this is called, which is SLAM, right? So, and using the cameras in front in order to map that space, those coordinate systems could change, as you move space to space. So what we do see, and we could see in certain circumstances, potential drift between the controller as you mapped it over time. And so, this review was really cool in the fact that it gave us the ability to use these controllers. What we would like to see over time is that use in the same space. Do you need to go back and effectively remap or recalibrate your controller to the space, right? And if something does get out of whack, is there a way to get it back in without going through a long process? So certainly something we are interested in as developers, and you obviously as well. But we don't recommend that. That's not a feature that we're basically going to support at HP. But it's something from the enthusiast community that we're very interested in. So overall, cool that someone was able to map the 2 coordinate systems together. Really awesome. Love to continue to see the future of this as we continue to advance the state of VR. So, and just kind of, with some closing thoughts here, overall, as a VR developer, I feel very fortunate to be on the cutting edge of building devices that are providing the highest level of immersion and visual fidelity. And I think, Reverb G2 really brings that forward. And, myself being a leader of some software teams inside of HP, we're not just looking at VR as in its current state today, right? We're really starting to look at what are the other things we can do in VR as somebody is wearing a VR HMD. And so what I'll just say is we're looking towards the future, and sort of in the near future here, we'll have some more exciting announcements about some of the new technology that we are going to be bringing forward, and really starting to take advantage of how great of a platform HP Reverb G2 is. So with that, I really appreciate your time. I hope that you were able to learn something about the HP Reverb G2, and hope to have more and more developers using HP Reverb G2, as I really think it sets the bar for immersive experience in VR. Thanks a lot. Bye. Hey everybody, thanks for watching that video. We're really excited about Reverb. So a lot of great questions already in the chat here as well. We'll start going through them. I also have John Ludwig here with me, product manager for HP Reverb G2 as well. And so we'll kind of ping pong around and make sure that we take care of all these great questions. So one that was asked early was about the controllers, and will the replacement controllers be available? We're really excited about these controllers, so we're going to have them offered as an aftermarket option, and make sure that they're available for us. We'll definitely have that available. I think John's already answered it in chat here, but we'll sell them separately. So that's a great question as well. Needs a hand-free desk stand, and that question came up, as I was talking about the flip-up feature of the device, And that's really interesting because, you know, early on in VR, when we were building VR devices, we were looking at the capability of actually 3D printing, because obviously HP has a huge 3D printing capabilities. If you haven't seen it, it's something interesting to look into. We actually built these stands that actually allow you to remove the strap and actually put the VR device on your desk. And this was really important for users of CAD, and people that we were going in and out of VR, you know, kind of quickly. We had a term called like VR snacking. You know, it was like you kind of bring it up to your face, take a look at it, and be able to put it down. So certainly today we actually have the 3D printed parts available, like as free downloads on our developers portal for the original Reverb and the Metal. But it's something we will definitely want to be able to bring forward with G2 as well. All right. Do you have any plans to add hand tracking in the future? Well, hand tracking is getting a lot of interesting traction today. I'm really excited about hand tracking. I see it obviously, you know, in other products as well. And you know, what I'll say is that, you know, really the camera and camera technology that that really powers HP Reverb is not optimized for hand tracking, right? And so we are looking at the future of hand tracking and figure out how we're going to bring that to Reverb and also to future products as well. Okay, let's see. I got a question about the trackpad. That came up as we were talking about the controllers. So yeah, the trackpad, you know, had the 4 buttons as well, up, down, left, right, and then we also had the joystick. So it is correct. I mean, we do have less buttons on the controller, but I don't know of any experiences that were actually mapping all of the controller buttons that we're seeing on that WMR controller. And if they were, for a lot of VR people that were actually being brought into VR, this could be a very confusing experience and actually very difficult for them to learn. And so you see a lot of, you know, obviously we're focused not only in the commercial space but also in the consumer space as well. We're starting to see those experiences not really map such complex controls. And you know, there's even experiences that really just use the finger trigger only. You know, but really, I think this new controller design is sort of hitting it out of the park. I think it really is a great combination of ergonomics, simplicity, and making sure that we have the right functionality inside the controller. All right. John, was there any questions that popped out to you here that you wanna answer?
See here, I think someone asked a question about standard 1.2 volt rechargeable batteries in the controllers. So the controllers do expect alkaline batteries, and so they look at their kind of battery capacity monitoring. So to expect that, so you can use 1.2 volt, but it works a lot better if you use a 1.5 volt rechargeable battery. There's another question about, will the 1080 be enough to power the G2 at 90 Hz without downscaling resolution? Certainly, it really depends on the content that you're running. So some content is really beefy, and some content's pretty light. So as always, kind of depends on what content you're talking about there. But certainly for lighter content or some of the original VR programs, the 1080 will run at 90 Hz without downscaling. Let's see, how strong is the cable? Strong. And let's see. Yes, someone asked about the USB-C to USB-A adapter. That is something that we initially were not including, but as we've gone through all the testing through devices and getting devices out to our partners, that's been one of the biggest things for us that has caused compatibility issues. A lot of people just don't have that USB-C port. So we did make the decision recently to include an adapter in the box for everyone. So you should see both. You'll see a cable that terminates in USB-C and full-size DisplayPort, but we include both adapters, both a USB-C to USB-A, as well as a full-size DisplayPort to mini DisplayPort adapter. So we're all about having that easy out-of-box experience for y'all.
We actually had a couple questions come in from the other live streams as well. Looks like really interesting one about flight simulator. That was really cool, by the way. I'm totally gonna sound like a nerd, but I actually played the original like Flight Simulator 3.0, 4.0 on my old computer, and so when I saw this come out, I was like, oh yeah, you better believe what I'm about to buy. So anyway, what do you think the performance will be with new Microsoft Flight Simulator running 4K in game settings? Yeah, we're gonna be. Flight Simulator's got a lot of texture, a lot of pixels to push. So we're going to definitely be seeing the upper end of cards to be able to do this to get the best experience as well, right? So obviously, that 1080 bar, right, that we talk about, that 1080 Ti, all the way up until the 2060 plus and 70 range as well. But I'm super excited to see Flight Simulator inside of the Reverb. That's going to be an amazing experience. Will there be any update in the Windows Mixed Reality reprojection settings? How will the move be smooth if the frame rate is less than 90 or 45? So the compositor, which is the main rendering engine of Windows Mixed Reality, right, is being improved upon by Microsoft, right? I mean, they are important partners here to make sure that this device is the pinnacle of VR, right? And so those things are being improved on, all the time, right? They're not necessarily dependent on the device as well. Obviously, we've tuned the device for the best optical fidelity display settings, right? Make sure that refresh rate is there. But how fast that game engine's actually projecting those frames to the compositor, right? That really depends on the content, how fast your PC is. And then the standard sort of interpolation between them as you're moving around, right? As you're looking around. So we see that just getting better all the time. And really, it like I said, it really depends on what the tuning is at the game and the game itself. So, and let's see, we'll go back. Those were from the live stream here. So let's go back to our Q&A in our chat here. Was there something you had up on deck there, John, that you were looking at?
There's a couple of availability questions about will it ship to Brazil? The answer is yes. A few others, we do have pre-orders live in Canada now, and I put the link in the chat there. We haven't announced an official shipping date yet beyond fall 2020. Someone asked, what is the screen? It's LCD. We like LCD because we can get a really high pixels per inch, so you get that really great density for your panel. And right now, as we make choices and we look at VR, increasing that clarity and that resolution is kind of it's the thing I get most excited about. Y'all can choose to debate that with me, but we really enjoy increasing resolution here. Let's see, what else we got? Any other good questions, Peter, that I've missed?
We got one about the light leak. I made a sort of a subjective statement about light leakage, right, in the Reverb G2. And I'll tell you something. I mean, when we were in the office, I sit next to all the mechanical engineers. I don't know why they put me next to the mechanical engineers. They probably annoyed with the fact that the software engineer has to sit next to them. But I mean, these guys are top notch, right? And I tell you what, the amount of work they spent on making sure that face gasket, that material, the fit finish, the modeling that they've done to make sure that thing is molded to the majority of faces, and the way the nose bridge is. I mean, it's just a great immersive experience, right? I have I'm not going to name names. I have other HMDs, obviously, around me here. I look at them all the time. There we go. Yeah, see, look at that. Yeah. And I can't tell you how great it is to put this thing on, right? I mean, it just blocks all the light out, right? And I mean, they just do a phenomenal job getting that design down. And I just think that is one of our superpowers at HP. I think we have an amazing mechanical engineering team, industrial design team. This device shows it, right? And so, it is a subjective analysis. It's hard to measure what that would be, right? But if someone wants to actually go measure it, I bet you we're number one.
I mean, if you look at our face mask design from G1 to G2, with G1, you essentially Velcroed on the whole fabric to the device, and so it was fabric and foam Velcroed to a rigid device. Now we have this whole plate here that magnetically attaches, and we actually built in some flex to this plastic backing. So as you put it onto your face, whether you're narrow face or a little bit wider, it actually flexes just a little bit to make sure you get that proper sealing around your face. So it's a really nice face mask. We spent a lot of time on this. We're pretty pleased.
There's a couple questions about tracking volume improvements. I showed a quick graphic, in my presentation, but really, I mean, putting the cameras on the side. Yes, of course, when you start to bring the controllers behind your head, yeah, it's not going to be visible, right? But the fact is that this volume on the side is so much more visible, right? And for so many experiences that the controller might be kind of away from the front of your face, and to make sure that it's tracked accurately away from your face. I mean, people test this all different ways, right? I mean, they go to their VR social app and they stand in front of the mirror and wave the controllers around, and it's cute. But I mean, I think that there's actual real use cases in commercial, not just consumer use cases, commercial use cases that really take advantage of the fact that you can bring that controller around and it's there, right? I mean, it doesn't get lost, right? And there's so much that's being done in the controller and the controller logic to take into account dead reckoning when it does kind of fall out of like the optical path of optically tracked path, right? To bring it back in. But I can't tell you how much better of an experience it is, especially when the controllers are sort of up and around this area that normally wasn't as well tracked with G1. All right. Let's take a look here. So yeah, a lot of questions about where it's going to be available. Yeah, I mean it's exciting. We'll get all that answered here. Let's see. What else do we got here? I currently use an Odyssey Plus. There's no screen door. The optics that good in the G2. Yeah, they're great. They're amazing. You're gonna laugh. I mean, it's like I put this thing on and I'm amazed all the time. You mean you'd think that I would be like, of course I'm used to it, but like I switch between it and I put it on. I'm like, wow, that's really good, right? I mean, it is that good, and the lenses are that good. So. The screen door, we're going to be to a point where we just don't talk about screen door anymore, right? I mean, I don't know. I just feel like, back in the days when cars had carburetors and we were talking about how hard they were to start in the cold, we don't talk about it anymore, right? I think screen door is going to be done, right? We're just not going to talk about it because we're setting the standard. All right. What else, John? We got a lot of questions coming in here.
What's the biggest glasses length that fits?
Oh, glasses. Yeah. Oh. Your glasses fit, don't they? I mean, mine do.
Yeah, barely. So I have this pair of glasses. It's like 140 something millimeters with really sharp corners. And funny or unfortunate story. These are made of acetate, and so we're not powered here on my microphone. So and I've been shoving my glasses into, a lot of different VR HMDs every day, and so I keep using them. And one day, right before we did the Reverb G1 press briefing, I flew to New York and I put the headset on, and my glasses just sort of broke in the corner. So I got to do all the press briefings for our Reverb G1 with a paper clip and a bunch of tape around my glasses. That's not to say that these are too big, but just be aware of the materials that you're shoving into it, because sometimes things go really poorly if you use like acetate glasses. So I actually generally, these will fit. These are like 143 millimeters, but for using different, I have a set of glasses which oddly get destroyed by putting in front of my chest. I wear a different set of glasses when I use VR. It's just a lot more comfortable. So these fit at like 143 millimeters, but it's just not that comfy, in my opinion. So your mileage may vary, but I would, for any glasses user, comfort is super important. So do check and make sure.
Yeah. So there was one. Maybe you, John, want to answer this one. How is the brightness of the panels compared to G1? I mean, and I feel like it's way better, right? I mean, it's perceivably a little bit better, right? But it's just enough where it's good, right?
Yeah, so these, well, So from a basic panel perspective, these panels are much, much brighter than the Reverb G1. Then, of course, comes the question of what do you set the persistence of for the panels, because how long you actually turn on that backlight is what determines the brightness. So for these ones, we don't give out a specific brightness specification, but the panels are much brighter. We actually lowered the persistence and made the panels bright and made the overall, nits after the lenses brighter than G1. And we're still looking at, we've had a few different, as reviewers and previewers have gotten their hands on it, we've had a few different persistences go out and a few different brightness levels, and different people have liked different kind of levels of persistence versus brightness. So we're still looking actually at what the right trade-off is for persistence versus brightness when we ship the final product, and that's something we're still going to keep dialing in and working on and trying out different ones with testers here as we go forward. But the panels themselves are much brighter, so you should expect both brighter and lower persistence from when you compare directly to G1.
Yeah, and that the fact that changed, we actually have, the cable is powered now, right? I mean, we have all the juice to the HMD to basically make all the persistence tweaks we need, right? So that's critical and very important on G2, right, to make sure that we get that high quality experience. Got a question about controllers being forward and backwards compatible. So these are Windows Mixed Reality controllers, right? They're going to have a profile. The fact that the new controllers do have a different layout other than the joystick, we absolutely So I think this is probably two questions here. One, as my application, how do I make sure that this works with the first generation and second generation controller, right? And so there will be a profile switch to make sure, and it's very, very simple to make, right? The other thing is the new generation controller from a tracking standpoint actually is backward compatible, right? So John, what is don't we have like a specific model that we're actually saying that we can use the new controller on?
Specific model?
I mean, we'll work on G1, right?
It'll work on any WMR headset.
Right.
So the G2 controllers are backwards compatible with any WMR headset from first generation to Samsung Odysseys to G1. And we will make them available to purchase separately from a headset. So if you are currently, very happy Odyssey Plus user, as one of our question askers is, then you want to upgrade your controllers, we'll be happy to sell those controllers to you. They'll probably ship a little bit later than the headsets will, but we are absolutely going to make those available for purchase.
Yeah, I bet you people are going to really want those. Those are really cool. They're really good controllers, right? So interesting question. Question who's responsible for iterating on the tracking and fidelity and SLAM improvements? So it's HP or Microsoft. So the answer to this is Microsoft obviously has been building a ton of the mixed reality ecosystem from a software standpoint, right? But without us together, we cannot build, test, iterate, and actually make improvements in the product, right? So really it's us as a partnership making these improvements, and the way it's actually implemented is great. The fact that it is part of the OS and the ecosystem is that Microsoft can drop improvements down with reasonable iteration, right? And it's not necessarily specifically tied to the hardware device. Obviously there's limitations of the hardware, right? I mean, we have the cameras obviously have a fixed quality and all those other things, but I mean, that's the reason why we pick extremely high quality components. That's why we build them the way we do, right? Is that we can continue to roll in those updates and changes. All right, let's take a look as a couple other questions here. Can you share play spaces outside of Steam? So I'm going to change this question a little bit. So Microsoft released a tool. So as I explained in my video in terms of like tracking and how SLAM works and the fact that I start looking around in my room and it's making landmarks and sort of mapping that space for me, Microsoft has helped us, especially for our customers that are in the location-based entertainment space, to share those maps that are built amongst the devices to make sure that they have very precision accuracy when you're in a multiplayer situation, right? And so that tool is already available today. It's available for Windows Mixed Reality developers who are building those type of experiences. We'll make sure to get a link in there for folks who are interested in it. But that's really how we make sure that those maps get locked between devices in the same play space. All right. Pass through. Everyone likes pass through. So we're Windows Mixed Reality has a flashlight mode, right? As you be able to point it and be able to see that space. We are using very similar cameras to what we used in G1. So the fidelity of in terms of pass through has not necessarily improved. Pass through is not. That's something we obviously think about. We see a lot of, right? That's kind of the future of how we start to blend full immersion with the real world. But right now, yeah, our sort of our pass-through modes are very similar to what we had in G1. All right. One that said, can this be used only with the front sensors in a situation that would simulate behavior of older models? Well, the tracking volume's increased, right? I don't know why you'd want to regress to a lesser tracking volume. I'm not recommending you put tape over stuff, but don't do that, right? I mean, why not take advantage of the extra tracking volume? So I'd be interested to understand a little bit more about that. But I think that in terms of the 6DoF tracking, that's very similar to what we do today. Really, the extra cameras help us do the controller tracking and really improve that controller volume. Not a lot of questions about IPD. What's the range? John answered that there in chat. 60 to 68 in a mechanical. This really helps. You really improve that sweet spot. As you're doing it. I think that the adjustment is very easy to use. Really helps. And let's see what else. What else you got there, John?
I'm just answering random questions now.
Oh, okay. You're multitasking. I'm
just typing away here. Someone asked about their thin laptops and RTX 2080 Max Q that severely throttles when not plugged in, and how people solve that. And the only way I know to solve that is with a plug, unfortunately, to a wall. It's the problem we tackled with our HP VR backpack, and we have to use big high output batteries to avoid throttling. The big problem here is that when you do that, it limits your ability to ship it or bring it on a plane. And there's a size limit on batteries that prevent that as well. So that's why you see that most big gaming notebooks end up at like 99 watt hours. But that means you can't get long battery life to actually go run without throttling.
I like this one. This is like, can I buy the G2 now and then higher end PC later? We talked about this half resolution mode, right? And so if your graphics card is good enough to run the half resolution mode, ultimately, I obviously would never want to say, have, less of an experience that we can actually provide. But, there is some upgradability built in here, right? Where you can run Reverb, a G2 on systems right now that might have maybe a little bit lower spec than we're sort of saying for the most premium experience, and bang, man, if you put in the latest and greatest graphics card, you'll be able to go and have the best experience there. So we don't publish specifically the specs about what that sort of low tier experience would be, right? But certainly it's sort of built in based off of what we do with the display and the display scaler. All right. Let's see here. Are you looking at adding eye tracking module? Is there room? Yes, there's room. That's the end of the question. All right. All right. Is the HP community where ideas are shared towards potential VR capability advancement? We listen to our customers. We love to hear from you. So Any ideas? So one of the things that we are trying to do and get out in front of people a little bit more, as developers and as developers of VR, is we're starting a developers portal specifically for the HP VR community. And so what we'll do is we'll drop a link and make sure that's available. But we'll have a form there. We'll have some ability to give feedback. So as a developer, if you have feedback about the products, that could be hardware, and also potentially some future software advancements that we do. We'd love to hear your feedback. I mean, that's how we make better products. That's how we did the G2. All right. I'm running out of new questions. What's the average battery life of a new controller? I don't think it's much different, right? I actually mine are pretty good. What, John? You have any a data on that?
WMR got a bad rap for controller battery life with the first generation because everybody was Bluetoothing back to the host PC from the controllers, and turns out that a lot of PCs had subpar Bluetooth, or when you get far away, the Bluetooth performance dropped off. So the controllers had to really aggressively amplify the signal out of the controllers to get that signal across, which burned through the battery life. Or when you go to a convention and all the radio waves are full. With the change that happened on G1 and Odyssey Plus, and now this with the Bluetooth in the headset, battery life is much, much improved, as you don't have those Bluetooth radio issues since you're just talking from the controllers to the headset. So overall, it's pretty good at this point. I'm not sure if we publish an actual spec since it differs based on where you are, but I'm sure we can get closer to
that. So a couple here that's coming in. Is there improvement to the lens compared to the testing units that were sent to content creators? Yes, even better. That I'm super excited about that. Yes, the lenses are better. And just the kind of we've seen some feedback about how G1 and the launch of G1. Let me tell you something. Not only do I lead the software teams in our XR group, I actually lead all the system validation around the hardware and making sure the quality is of top notch. And this is something we focus immensely on for G2. And so we are very confident in the quality of this device at launch, and to make sure that it's going to provide a premium experience here. There's things we've learned, of course, right? As you build hardware. Building hardware is not easy. I love to hear the sort of the armchair hardware engineers love to make criticisms, but it is not hard. It is not easy to do it in mass, and we are spending a ton of time making sure that this is of the highest quality, right? And so we will have a great product launch for G2. Let's see. What else do we got? WMR be updated regularly? Yeah. I mean, this is the go forward platform, right? I mean, this is going to be there will be updates. I mean, I'm not going to speak for Microsoft, but I mean, this is a great device, so I don't see why not. We keep improving it. All right. Let's see. Have any showrooms to try? Well, physical devices are hard right now, so we're gonna, for people that don't. I mean, you assume a future, right, where eventually that we'll have these devices in retail locations, where people can actually go and test them out before they buy them. But obviously, I'm not going to go predict the future and tell you when that's going to happen. But of course, as soon as we can, we'll make that happen. And here I'll do one more here. Is high FOV important to HP in the future? It's a loaded question, right? I wouldn't say FOV is the only metric, right? I think just general immersion and the experience is important to HP, right? And so as we see people chasing certain numbers, of course, right, we'll be criticized and potentially even be limited in certain areas. But we feel with Reverb G2, the FOV that we have with the optical system that we've built provides an amazing level of immersion. Obviously, there's systems out there today that provide a higher number of a higher degree of field of view on paper, and you put them on, and you can be the judge in terms of how you feel the optical quality is and the immersion. So there's a point where there's basically a sweet spot that we're trying to hit based on a lot of factors, right? Like how great these displays we can get, how much bandwidth we can push across DisplayPort, right? The system you need to power it with, right? I mean, if you want us to go build the ultimate VR HMD with infinite pixels and infinite FOV, be prepared to have an infinitely priced PC to drive it all, right? So we are definitely making sure to provide the premium experience with the technology that is on the cutting edge. All right, John, did you see any more that you wanted to answer there?
No, I think we're slowing down, maybe. Let's see. There's a lot of people asking questions about future VR at HP. The one very hard rule for Peter and I, or any HP employee who's talking to people, is we cannot talk about future products or any future planning. Otherwise, we never get to talk to you again. So that's the one rule that we can never break. But we watch. There's HP Reverb on Reddit that we have an employee always looking at every day. So thanks to Voodoo Max. And so if you got suggestions, that's probably the best place to go, honestly. Because otherwise we can't comment on future product. And
yes.
Let's see. A couple people asked if there's volume control on the headset. There's not. You have to do it through the menu. So you press the Windows button, it brings up the Windows menu, and that works whether you're in WMAR or if you're in Steam VR, and then you'll see volume changing at the top. But there are no physical volume controls on the headset itself. And let's see.
So I think
I think we're about wrapped.
Yeah.
Yeah, no, it's good. No, it's good. Great. No, great questions, everybody. Very, very great questions. We're super excited about this as well. Obviously, as we mentioned, pre-orders available in a lot of places right now. We're making sure that's going to get, available in all the spots across the world as soon as possible. So, with that, we'll make sure that go visit our site hp.com, right? Go search for Reverb. Take a look at the specs if you missed anything on the presentation. Otherwise, hope you got a lot out of this. We had a lot of fun putting it together and presenting it to you today. So, with that, back to you, Nick.
All right. Thank you so much. That was a lot of really cool details that I don't think I've seen anywhere else. So thank you so much. We really appreciate it. That was amazing. And then for everybody who's attended and stuck with us for all of this content, thank you so much. If you weren't aware of this channel already, the Meetup group, we do regular presentations about mixed reality, HoloLens stuff, VR stuff, all sorts of different things. So if you are interested in seeing more of this type of content in the future, then please make sure that you sign up for the Meetup, get some notifications for when we do these. It's usually multiple times a month. If you go to aka.ms/mrmeetup, this is the best place to go. And then we also have a newsletter where we will let you know about certain things within what Microsoft is doing. So aka.ms/iwantmr, it's a little bit of a developer survey, but it signs you up for our newsletter and you get all sorts of cool bits of data. So thank you everybody for coming by. That's all that we've got for today. So please enjoy the rest of your evening or morning or whatever time zone you're from. Thanks and take care.